Hello, hello. Hello, hello. And today we are streaming and working on Cast, the programming language. All right. Yes. So last time I was trying to make the stuff work, the higher kind of types, dependent types, and I think I kind of got it off stream. So it almost is working perfectly. So yeah, let's see what what's up here. Hello Pigorli and Penguin Operator. So I have this example monad, right? And I was trying to make it work, and I kind of made it work. So we start with a functor, which is defining the fmap operation. We have the functor of a, and we have a function that converts a to b. Then we can get the functor b, right? And that worked. We can implement option as functor. We can write generic function replace all, which works for all the different functors. So for example, since I only implemented the functor for options, we can say replace all option with world, which means that instead of hello, we get the world back here. I feel like let's actually do this for lists. How about that? Too. We have options. We also have lists. Those are the two simpler examples, I guess, right? You spelled nomad wrong. Hello, Valdek. Let's see. Implement a list t as a functor. Right? We have lists. Fmap is. So I just have I literally have a list map, but I don't have the list map function right now, right? The type should be though this, which has a list of A's and a function, and it returns a list of B's, right? That's the type that we expect here because that's what functor is about. Okay, but we can implement that separately, right? So we have A, B. If we have a list, which is a list of A's, and we have F, we can actually use the inference here, right? We have A and B, binary 2. I don't know what you mean binary 2. That's I was confused there for a second. Oh, your 10 streak. Oh, I see. Okay, got it. A 2 stream streak. Nice. Did you start solving your advent of code as you planned? So how do we map a list? We can create something stupid where we create a new list all the time, right? So let result be a list create, and then we like list iterate. We iterate over list A, and we have a function that takes x and return, and it does the list push back result f x, right? This is not ab, this is af, right? Like that, and then we return result. And then this type checks, right? So we know that a in this case is a list. Wait, I mean, this says type underscore, so this is not correct. And f is underscore underscore. So we have some problems. It was very close to start today, but you decided to procrastinate. Nice. So I have still some issues with inference here. I feel like this should be inferred that this is a list of A's, right? Because that's what functor is expecting. I mean, if I look at this here, that's what we have. That's what we have. Yeah. We already have list A here. A and B. Also, it doesn't say that A and B are types. So, like, it feels like the inference here is not ideal. But anyway, let's try. So we have replace all, which works for all the functors, right? Let's say that. So we have an option, which is some 1, 2, 3. Let's say that this is an option of integers, right? I have already tried the monad, so like that works. But I want to try some more stuff here. Can I just like maybe functor should be like its own example or whatever. Happy Nora, hello, hello. Nerdzel, hi. Maybe let's have like HKT stuff in its own thing. So we have multiple examples here, right? We will have functor, and we will have the monad as a separate example here. And my workspace roots is going to be examples HKT star kids like that. Okay, so let's remove everything that's not about the monad from this example and move this into the other example. Let's also have a like simple ks or whatever, which is this like type function and stuff, right? Yeah. Use std prelude store. Use std prelude star. All right, so we want to see what is missing from me having actual HKTs in the thing, in the language. Chat is cast build today. What does cast build mean? Type function. Type function. No overlay. What's overlay? The chat overlay? Doesn't work again, I guess, for some reason. No, it says, yeah, see, it says connected to chat. Oh, wait, you were disconnected from the server. Oh, joined, okay. One. Yeah, now there is chat overlay. I don't know, I just refreshed it a couple times and it works. Weird. Anyway. Yeah, so here's the functor, right? And we implement functor for an option and for list, and we want like some function that works generically for all of the different functors. Type function which implements the functor, but we don't specify that a type implements a trait yet in the generics. We just say that this is a type function, which is a type, which is t type into type, like that. But I want to like specify this easier, I think, too, right? Like we don't say that this is type into type. We say that this is type, right? Because that's a different thing. Oh, wait, I think I know what I can do. Like, it's a little weird, though. Would it be weird if we have this? So, what if I had different syntax for defining the generic type and generic itself? You know how, like, if we have a function, then the syntax is like argument into body, right? But if we have the function type, then the syntax is argument into body. It's the fat arrow versus the not fat arrow, right? But for generics, there is no differentiation between the syntax. But we want to have the differentiation, right? So we can say that generic is t into t, but the type of G is t into t. It's a little bit weird, though. I feel like it would be nice if I don't do that. Arg triple equals body. Well, I mean, also we want to specify this. I mean, the bigger issue is that this is basically like a dependent type, right? So the problem is that this over here is a pattern and not a type, right? That's the problem, you know? So when we have a function, the argument here, so this over here, you know, is argument type, and this is body type. This is argument, which has the type argument, right? And this returns body. If I want to specify the type of a function, if I want to specify the type of a function which is dependent, then I need to give the name to the argument when specifying the type too, right? That's why this over here is a pattern. But it means that, but sometimes we don't want to give it a type because it's not dependent, right? Do other languages do different syntax for dependent and non-dependent types? What are programming languages with dependent types use different syntax for dependent versus non-dependent functions? So this is n nat into vec int n, right? Like, but the problem is that that's not how I parse it. The arrow is that the same arrow that is used for non-dependent functions. The only difference is that the right side uses n, and now it's dependent, and non-dependent is just this, right? So the thing is, this over here is a pattern, but this over here is an expression which evaluates to a type, right? I differentiate between the two right now. Because if we treat this as a pattern, then we actually just get the net, which is a variable of like unknown type, which can be used on the right side. But since I'm specifying the type, some languages distinguish implicit versus explicit parameters. Yeah. Do as told by AI master. Resistance is futile.
Hello badcop_.
Hello badcop_. All right, I'm just trying to think of how would I do this. All right, the syntax for dependent stuff, because I want it to be nicer. We can always ignore the syntax and just use what works right now, because there are other issues. But so why will this not work right now, right? Why will this not work right now? Because when I specify the function type, this is an argument, which is this over here is a type expression that's expected here, right? So if I say a type expression argument is type, basically, right? Well, I mean, no, we say like A is arg, right? So this basically is the expression which just has the type annotation. Over here. This is just an expression which has a type annotation. Like, the thing is, with the type annotations are optional, right? So when you see something like let's say that we allow dependent type like this, dependent function type is, you know, A of type, A, which is a type, no, A of type A into B, right? That's the dependent function type, right? If we allow this, we want this, like, the type annotations are optional usually, which means that this should be removable. And if we remove it, then we just write it. If we remove it, then we just write it as A into B. So how is that different syntactically from A into B? There is no distinction, right? But in this case, I want this to be a pattern so that I can use the A on the right side. And in this case, it's not a pattern, but a value, which is the type A. But if we are writing a dependent function type, I'm guessing that the dependent function languages, they are not allowing for this to be omitted, right? Can you omit type annotation for n and have it inferred? So like f is n into vec int n, right? Because in this case, I feel like it's not going to work. No, because this is ill-typed nonsense in every, say, independently typed language, because n is not a type, right? Because on the left side of the arrow, we expect a type. Arrow expects a type on the left, not a value, right? So we must, so it cannot erase the thing. But technically, this type can be inferred in a lot of I mean, I actually am inferring the types, right? For example, functor, in this case, A is a type and B is a type, right? A is a type and B is a type. And I don't want to specify that this is a type, right? Which makes it weird. So how would you do this in a dependently typed language? How do you specify generic types then? Aren't they just functions taking types and returning types? Do I have to annotate the generic arg that it has to be a type? Yes. So list is type into type, and you have to annotate this, the sugar that is this. Without that, the checker has no idea in which universe the A belongs to. But I can infer it based on like the thing. Why can they not infer it? Well, but it can be inferred that A is type by looking at the body of the function. Language too powerful, syntax cannot catch up. Like, does it mean that I'm trying to do something like too flexible or something? Like something that like existing independently typed languages cannot do? In a fantasy language with an oracle, it could be, but in a real dependent type system, no. Yes, generics are functions from types to types. No, you cannot reliably infer that A is type just by looking at the body. Here's why. The body is checked after the binder is known. Type checking is not psychic. The checker does this. Read binders, put them into context, check the body using that context. If you write F A into A before checking the body, the checker must already know, is A a value, a type, a universe polymorphic thing, a proof, a black hole? Well, I mean, so it like if ChatGPT is right here, then the inference algorithm that is used in the existing independently typed languages is different from the algorithm that I'm using, because I definitely don't need to do that before checking the body right now, at least. What if ChatGPT is wrong? There's no way. I mean, actually, like I have not seen it being wrong a lot of times when I'm asking it about this thing. Like, you see, it's this, like, it is disagreeing with me. When ChatGPT is like, yeah, I can see it being wrong with it when it agrees with me. But if it disagrees with me, then it's like 99% correct, I think. No? Is that not the case when you use it? It always agrees with you, so I'm onto something. I don't know. It like yeah. I feel like lately the questions I have been asking ChatGPT, it disagrees with me a lot. I was using like I was trying to use like other LLMs like DeepSeek, and DeepSeek is agreeing a lot. Yes, and it is lying a lot. ChatGPT is like nice and useful, I feel like. I guess it depends what questions you ask it to, right? Network connection lost. Where's my network? Is the stream online? Used as a type is not reliable signal. You are thinking, if A appears where type is expected, then A is a type, but that fails immediately because independent types, values appear in types, and types appear in types, and types depend on values. I mean, yes, sure, but like, if I infer, I can just infer that A is a type, right? Because like, I know that something, that the type of something is a type, right? That's weird. Let's actually try this. Okay, let's see if the ChatGPT is lying. Sure. 10. Idris. You know what? I should probably have like Flake Nix here. Inputs. Outputs. Never mind. Let's just copy. Yeah, sure. Let's copy that Flake. I don't need to cast. I'm just doing this. And packages this, that. Address 2. Right. Let's also have the GHC installed here because why not? Let's have Haskell, let's have Idris, let's have everything here. All right, I'll test something. And to like get good at writing it because like every time I try to write Idris, I just I just cannot do anything. What if I refresh? Something went wrong. Something went wrong? Wait. So I refresh and I don't see the answer that it was giving me, really? Feel like your brain is now running in a Docker container? Have you not worked with Dockers before? Full inference would be undecidable. I mean, sure, we do have some annotations, right? I don't want to do like full inference. You have just introduced higher order unification with universes, which is undecidable. But the bar supports this. Sometimes yes, always no. Example, ambiguity. This. Is this identity on values, identity on types, identity of proofs, identity as type 1. You understand it less than Nix, Docker? I know, I feel like Docker is pretty easy. By the way, they are saying over here, type checking is bidirectional, right? So bidirectional is a different algorithm than the algorithm that I'm using. You check the bodies against known types. It means that when you are type checking a function, you know the type of the function, which is not necessarily true for me right now, right? Are there dependently typed languages that use unification instead of bidirectional inference? No, not in the way you're hoping. Why doesn't my ChatGPT always say no to me? Why is it always saying yes to all the other people and to me it always says no? Long answer. With the sharp edges exposed. Pure unification. Plus dependent types. Dead on arrival. That cannot coexist with full dependent types. The moment types can mention values, unification becomes higher order, universe polymorphic, value dependent. The problem is undecidable, not hard, undecidable. They use unification as a subroutine, not the driver, whatever that means. How do you fix your problem? You have problems with permission in Docker? Have you tried asking ChatGPT how to fix permission issues when using Docker? This is what you want. Your containerized files owned by root and your host cries, right? That's your problem. So you just run the container with the user being you, the user, inside of the container. I think. You cannot run it as non-root because it does something in the USR. Not using the cache. I guess your second problem is that this thing. It's weird. Let me see here. Project Linksider, right? If I say over here, just build Windows. Or am I also doing the same thing? It does cargo gang build, which calls cargo metadata. This over here is not, you don't see anything here because it's fetching the cargo, the crates.io index, I think. Let's copy this command and let's say that not cargo build, but just cargo build release target x86 64 PC Windows GNU, right? Like this. There we go. That's what it's doing. Now you see what's happening. So, okay, let me just stop this. But I cannot control C. That's weird. I don't know why I cannot control C there. But yeah, if I try running this again. Let me just see if it's going to download all the crates from scratch right now. Seems like it's doing that, right? Yeah. Okay, sure, I can... We can see what... We can see. So the problem is that that there is the cargo. There's like another environment variable that you need to set or something. Cargo, cache and variable. Cargo home maintains a local cache of the registry index of the git checkouts and of the crates. Isn't that all that you need to do? You just say something like env cargo home is target Windows cargo, for example. Can I find cargo toml in source or any other parent directory? Why does that not work? Oh, because I need to, yeah, because I need to go project Slinksider. I thought I had that. Let's see if that happens again now or not. So I downloaded some crates, like, I mean, over here, right? I already downloaded almost all crates. So let's kill this and let's rerun this. And it's downloading only 28 crates. Okay, that's it. That's what you need to do. You just need to set the environment variable. And that's what it's using in /usr. I guess the cargo home is there by default. I'll add this to my own just file too, I guess. Build for Windows. Cargo home is target windows.cargo. Cache downloads when a building for Windows. All right. Anyway, that was Nertzl issue. Back to cast. Yeah, I guess it's because I was never I was not building for Windows that often. I only did it a couple of times, so I didn't see the problem. Okay, we're trying to figure out the syntax for dependent types. And so currently it seems like the syntax for dependent types, you cannot omit the fact that your like argument here, like, is this even a pattern though? Like, that's the question. That's the question. Let's see here. So I have the Idris installed now, right? Can we say that we have a dependent function, ID, right? ID, like this over here is already like weird, right? If a like obviously this is a function that returns a into a, right? This over here is a function. Like just looking at this, we already know that a is a type, right? So why do I need to specify this here? Should this not be inferred? Can I do underscores in Idris like this? I can, right? Okay, but now, since we're basically annotating something with underscore, it seems like this annotation is useless, right? So like, why don't we just allow this? Well, because this feels like this is the a that already exists, so we need to introduce the new variable, which is why introducing the new variable needs to use a different syntax than using this variable, right? But this is a little bit weird. So and right now, because of that, I do different syntax for generics and functions cannot be dependent, and generics are always dependent, basically. Where dependent is like a into a. That's my current syntax, right? So in square brackets, we always see a pattern, and over here, we always see like the expression, which is a type. Which makes sense, right? Yeah, but the problem now is that when I want to specify the type, of the type of for example, like if we know that option is the thing which is type into type, right? This is a type constructor. Does it mean that it should just not like, because like right now I'm also treating this as a generic, and because it is a generic, this over here is a pattern which is expecting that I'm introducing the new variables, so I do instead underscore is a type, and this makes it like annoyingly long. Figuring out good syntax for dependent types. So I still want to write here something like type into type, right? I mean, yeah, but interesting. Maybe I should like just get rid of the distinction. No, I should not. This is not the only distinction between the generics and the functions. The other distinction is that the square brackets can be omitted. Square brackets means optional, which means that I can use inference. But hold on. But as ChatGPT says here, in Idris itself we have the implicit arguments, which are surrounded with curly brackets, which is very similar to what I'm doing. But can it be that implicit argument? Can it be that implicit argument in this case? Because it's not present on the right side of the arrow here, right? Obviously. Yeah, like now this name is useless. Now this name is useless. Can I omit name of implicit argument if it's not used on right side of arrow? Yes. If the argument is implicit and not referenced in the rest of the type, then most of the dependently typed languages let you omit the name and just write the type. The only rule, you only need a name if the result of the type depends on it. So you're like, yeah, you can just say type, right? But now the problem is the same, right? We parse this. Yeah, so like there is two different things. There's two different things. Sometimes, so for some reason they cannot infer that this is a type, right? So we have two cases. The first case is this, where we have where the type should be inferred, right? So I want to get rid of this colon underscore here. And the second case is where the function, you know, like, I don't know, higher kind of type or whatever, right? It's a thing which is a type which returns a type, right? So in this case, the useless thing is the value name, and in this case, the useless name is the value type, because that can be inferred. So if I just get rid of this in both cases, then we're just going to see like a, and in this case we're going to see just type into type, right? So how do we differentiate? There should be some syntactic difference still. That's the problem. That is the problem. And then we have already the distinction. Because this over here is the implicit argument. But whether the argument is implicit or not, kind of like, is not necessary. But right now, it's just for implicit arguments. I parse them as patterns. And explicits are that. Which is why this is how we write that. I feel like I'm almost there. I can come up with a good syntax. Well done. Let's say that that we have actually figured out how to infer the fact that infer the type of argument dependent function. Now I want good syntax for specifying that. All right, let's just see what it says. Option 1, whole binder. No. Infer the type of this argument. If dependency is needed. N is bound, but the type is inferred. Okay, so we just do underscore N, which is still wrong. Kinded arrow. Visually explicit, slightly heavier. This means dependent capable arrow. And introduces a name with inferred kind type. Well, I mean, actually, yes. When we have a function in like Haskell, right? We have if we have a function ID, right? What's the type of ID? ID is going to be basically for all A into A, right? So in this case, the kind of A is being inferred, right? Can you specify explicitly in Haskell? Can you in Haskell explicitly specify kinds of polymorphic params, I guess is what they're called. I'm not sure. Yes, Haskell lets you do that. It briefly pretends it's a dependently typed language. F type kind signatures. hold on. Show me how to do it when specifying type of ID function. Yes, yeah, okay, yeah, there we go, right? So you literally say that over here, A is type, right, like that. There you go. There you go. So that is like similar to what I'm doing already, right? Because this for all clause, it introduces the yeah, the types, and like you use that type over here. If you don't use the type on the right side, if you don't use the type on the right side, then it is not a for all basically, right? Like what is the is there kinds that have for alls? Right, like what's the kind of actually like, so yeah, the explicit syntax in Haskell is something like this. This is type or whatever, right? And this, all of this can be inferred, obviously. Now, if we have a higher kind of thing, like what's the type of option, right? The type of option is type into type, right? That's the kind of it, which is the type. But how is that different from saying something like for all a type, a into type? Is that like different, or is that the same thing? Yes, that is different. That's not the type of option, no. We actually just have the type. Because it is just for all a type, basically. That's what I do right now. Why not? Because option takes not the value of type A as an argument. It takes a type as an argument. Wait, hold on. I mean, yeah. Wait, what? Why not? Yes. Is this a different thing? Yes, it is a different thing. Yeah. So yeah, because yeah, the argument is of type A, right? But the argument must be of type. So the actual definition is this. And as you can see, the difference here, if we talk about Haskell, that you don't see this argument, you don't use this argument on the right side, which is basically what we are saying, right? This means that this is a function which is technically not dependent. Right? So this is a regular generic, and so since this is not dependent, what you do is that you say that the option is just type into type, right? You like instead of the for all clause. But I still want that to be different. Why? Right? Because functions are the things that must be called explicitly, and for all can be omitted. That's the difference. That's literally right. So in Haskell for all, in my language, we just use the square brackets, right? So a type type. That's the type of option. And I cannot say option. Well, I mean, for options specifically, I guess I can, but if we have a function, you know, if we have a function, a generic function, if we have a generic function which works for all, A, which is type, and we just how do I make sure that it's not used on the right side? If we have functions. And this is like generic. I feel like if I have a parse, it would be something like this. Am I imagining that I have a problem? So the only problem is for types, right? For functions, if we have the generic arguments, then it's... Does it have to be used here? I mean, not necessarily, right? Like in Rust, you can definitely write a function that does not do that, right? Like, yeah, literally, you just have like function which is default, right? So default is a function that works for all types T, right? And it's just unit into T, right? Wait, no, but this over here has the T on the right side. No, hold on. Let's say unit into unit, right? And this is going to be like, you know, it's going to be like print type, you know. How about this, right? Like we should be able to write something like this, right? So we say print type, which is T, unit into unit. T is type, but since T is not used in the value, we want to omit this. Then this is just like some type, you know. Why? But practically we have that problem in specifying the types, not functions. But this doesn't work. I don't know. There's no good idea that I have. Do you have an idea, Nertzel? No? Okay. Let's ignore this. It's just like weird. Maybe I can have I mean, we will always also want to have actual dependent functions at some point, I think. In which case, this is also weird. Maybe. I don't know. All right, yeah, the problem is that over here, when I specify the code which works for all of the different functors, the functors are basically like so we are expecting something that has kind type into type, right? But it's not what it is because it's not a function like this, and it's instead this, which is different. Should stream earlier, then I have some ideas. I don't know. Okay, wait, hold on. I have like another idea. What if we use an arrow here and that's going to be my special syntax? So if we use an arrow, then it's like that. But if we don't use an arrow, then this is a pattern. And if we use an arrow, then this is a type. You know? That's weird though. That is weird, but I think this can work. Let's just try using that. Introducing the syntax is easy. So for generic, this one, we're just going to have another syntax here. Why is it 6.5 and why is it defined over here instead of it being defined over here where it actually belongs? Weird. Yeah, so we have like generic, and then I want to have a generic non-dependent, I guess, which is going to be argument, and then arrow, and then a body, right? Like this. That's the difference. This one has the arrow after, and this one doesn't. And then we go for syntax, and we just say that we just do syntax argument into body is basically equal to the syntax where we have underscore of type argument and we return body like this, right? Okay, I think this might work. So now in functor, I can actually do that, right? So this is fail to pattern match functions argument. I think this is the priority. I need to like change the priority here a little bit. Okay, yeah, how do, let's also try fixing the priorities here. Why is the priority of this inferred? So like this should be higher priority than the type ascription, right? The generic, why is it not? That's the question. Maybe like the priority should be different here. Type ascription. Well, I guess it's because I want this to be this one is a little bit of a weird syntax. Like we want like on one hand we want to initialize the field to the generic, right? So it should be higher than this priority over here. It should be higher than the comma priority, right? Right, where's the type ascription? Oh, type ascribe, yeah, type ascribe is priority 8, right? Wait, it should be higher than this and it should be higher than that, right? Wait, why don't I just move this over here below the type ascription? What about the function type? Isn't this the same priority as the function type? Function type should be right associative. We don't do association right now, but like shouldn't it be the same priority here? 8.5. And I can add the associativity to the function arrow. It seems like that breaks a bunch of things. So why? Why does that break a lot of things? Because things are parsed differently now, right? Okay, let's see how this is parsed. Like that. That's how it's parsed. Okay, I see. Because it thinks that... Yeah, because like the value of this generic is this function. Wait, no, that's correct though, right? Wait, what's the problem? What is the problem then? I feel like this is parsed properly. Generic cannot be a pattern. Oh, it's because I did not. It's because I did not restart language server, so my LSP is not showing how it's parsed yet. So now it is not parsed correctly because it thinks that the argument to the function is this. Because this is parsed like so. Makes sense. So how do I prevent it being parsed like that? I don't make it right associated with the arrow. So I need it to be a lower priority than the function, which is why it was over here at 6.5. Yeah. Why is the function type as at 8.5 then? Maybe like I move this also to 6.5. Maybe I just move that to 6.5. Syntax priorities are difficult. Still a lot of stuff. Okay. In before all syntax is broken. Okay, I mean, now we have the error in the different place over here. Because it says that, yeah, because now type ascription is higher priority than the function type. So this must be put in braces, which I don't want to, right? We need type annotation, type ascription. We need type ascription to be lower priority. Okay, can I move type ascription lower priority? Not really, because for like it should be like here, yes. Okay, but can I move this lower priority? Maybe. So the only thing that we need is the function. That's the function definition. Can I move the function definition? Yeah, should I be able to use if? Should I be able to use if in the function definition? So I should return if that, then that, else that. Yeah. We'll do type ascription here. Type ascription makes sense for all of these other ones. Wow. Because this over here is a pattern. Yo, Dev Ninja. Hello, hello. Welcome. Welcome, guys. How are you doing? Did you work on your language today? All right, I'm trying right now to have better to fix my syntax in my language, specifically for like functions and generics and stuff. Works on a side gig streaming heart rate data to OBS applications like games. I see. This last 30-50 minutes talks about programming languages. All right, what did you talk about? Which programming languages? Did you talk about how bad all the programming languages are, which is why someone needs to create the one that doesn't suck? Like, you know, basically. All right. All right, I'm trying to like move around the priorities for my syntaxes so that things that are parsed nicer than before. Specifically, for example, right, I want this to be parsed, right? We have the annotation. So we have annotation, and this is the type of the function. So f is the function from character to unit, right? So because we want this to be parsed, it means that type annotation, which is the colon operator, should have a lower priority than the right arrow operator, right? That's what we know, right? Then we want to have generics, right? Let's maybe like simplify a little bit. Let's just open something. Yeah, let's open like this thing. New. Let's open this. I talked about my experience doing Advent Code in Go last year and in Rust in this year, and then that I'm porting back and forth to compare. Which one do you like more? I feel like for Advent Code, it's not really like showing you the strengths and the weaknesses of the language properly. I feel like for if you just try for Advent Code, I would guess that you like Go more. But I don't know. Can you generate priorities from a directed graph? Well, you say Kappa there, but there are programming languages that actually do that, and maybe that's what we should do. So this is a programming language called Swift Custom Operators, and they actually do the directed graph. And then they basically generate the priorities for you. Right? Where's the definition how to do that? Though someone like, yeah, over here you say addition precedence. Addition precedence is basically like the it's basically the named priority, I guess, right? How do you specify the things? Where's the documentation? Why is none of the links here put me to the documentation? Rust, actually? Yeah. Okay, nice. Good choice. Good choice. I approve of the Rust choice. Go is trash. Never go back to that language. All right. How to define a custom operators in Swift and specify priorities. Caster write in Rust when? It was it's already happened. Yeah, there you go. You call this precedence group my custom precedence, and then you have higher than addition priority. This basically constructs a graph, right? And then you generate the priorities automatically. All right. What happens if you introduce a loop? I mean, a loop of precedences. So we have a precedence group A, which is higher than B, and precedence group B, which is higher than A. Swift will refuse to compile, right? Cycler dependence precedence relationship. You think we should do that instead of like the numbers when caster, right? in the one and only Haskell? No. With the next rewrite is the rewrite in the language itself. Haskell. We love it, but we don't want to use it. All right. Anyway, let's. Since I don't have this functionality right now, and I'm not sure if we should. Numbers are kind of like nice at the same time. I don't know, but they are. Yeah, I don't know. Maybe that is better. We'll see. Okay, so we have here's what we want, right? We want to be able to write function types, right? Which is argument into a result, right? We want to be able to do type annotation, right? Which is like value is type, right? Right. So this is a function type. This is a type ascribe, right? Then we have generic, which is you know, t. I don't know. I mean, we call it also like argument body, right? Yeah. So what do we want? What do we want, right? We want to be able to specify generic functions, right? So we want to say like argument, you know, like, I don't know, let's say like t into t, right? That's like the type of the ID function, obviously, right? Can we say like, do we want to be able to say like t into u, for example? Should this be possible? Maybe that should be possible, right? Which means that these things should have the same priority group. And they should be like right associative, right? Because if you have the function a into b into c, it's supposed to be parsed like this, right? If you are having the generic, which is like t and then u, you know, t into u, that is supposed to be parsed as this is the function type and this is like that, right? Okay. YID x times x is also t into t. X times x squared is also t into t. I mean, yeah, this is the type of ID function, but it's not the type of ID function and only ID function, right? There are other functions with the same type. Sure. Maybe instead of higher, less than, would be easier to read if they're required to be in order. But you cannot do in order. Like, I mean, I'm trying to maintain this thing to be in order, but not because we have like custom syntax where you can define your own syntax outside of this file. That's how you no longer can keep everything in order, because the things are in multiple files. Similar to Swift, right? Because it's a custom operator in the user code outside of the standard library. This is the syntax of the standard syntax defined in the standard library, right? So yeah, how do you keep in order when it is multiple files? Okay, so function type and generic are the things of the same priority, right? For sure. So we must say that function type and generic is the same priority. Then what about the type ascription, right? So we want to be able to say that f is a into b, right? And obviously this is the type of f. That's how we want to parse it. We don't want to parse this as f a into b, right? That's not what we want. Which means that order of priorities, it means that like type ascribe is lower priority, right? Than the function type and generic. Okay. Then we also have the actual function, which is not the function type, but the function. Right? Let me see what I do right now. TT is end functor on same category. Just make operator precedence lexicographical. So that instead of the numbers, you put the names. I mean, that's one of the reasons why I allow floating points, so that I can always put something in between, right? Yeah, I don't know, lexicographical. I feel like that's more difficult to understand what's higher and lower than the numbers, though. TT is end functor. It transforms values, not types. Wait, what is an end functor? I have no idea. Let's see, end functor. A functor that maps a category to the same category. It transforms values, not types, right? But T can be a type. So, I mean, it is an end functor because a value is just a value is a category too, right? I mean, is a value a category? Is category a type? Right? Because we treat types as values, well, there is no difference. TT can be type into type if T is type. I don't know. Is a single type also a category? Well, what is a category? I don't know. I don't know this theory. Isn't this like the set, basically, right? Same as the set? Kind of. It's like a set plus some operations, maybe? I don't know. I don't need to... I need to not be looking this up. But, like, a category is like a set of types, and a type is a set of values. But if you treat types as values, then what's the difference? Right? I think the problem is that we're mixing category theory terminology and programming terminology. Yeah, that's why I'm trying to like not use these nerdy words. But I mean, yeah. Categorizing is just over abstract. Yeah, I don't know, maybe. If you know category theory, then though it's probably Yo Cakes with another raid. Thank you very much. Hello. Time for some cast. All right, I'm trying to figure out the syntax right now, guys. Welcome. I'm working on figuring out the syntax right now of my like functions, generics, and like stuff. I'm making a programming language, if that's not obvious. So I'm moving the syntax around. The language is based on expressions, and everything is an expression with different priorities. So we need to figure out the proper priorities of all the different expressions. For example, for declaring the function type, we say like argument returns a result. That's the type of the function that takes the argument of type argument and returns a result. So ML-like. I mean, in this specific case, it's ML-like. It's not like we are having inspiration from all of the different things. Do you not like ML-like syntax? For generics, for example, I'm using square brackets, which is more like Go or Python though than ML. We also have like some stuff from like Rust, like references or like other things. What am I trying to show? Yeah, like we just define the mutable variable like this, and then we just say I plus equal 1, you know, just like your normal code. That's something that you don't really see in ML-like languages, right? Or like for loops, we still have that. All right. Let's try to make progress. So far we have determined that type ascription is lower priority than function type as generics, right? Because we want to be able to say like that X is of type T into T, right? So in this case, this is being parsed. This is the lowest priority, so this is the thing, right? And then generics and these are like right associative. So this is being parsed as that basically, right? Which is what we want. So generic is priority 6.5 right now, and function type is 6.5. These are all right associative. And type ascription is of priority 8 right now, which is completely not aligning with what we just figured out. So let's do this, and then if I do this, we're going to see the issues because I have existing code which doesn't parse since I'm moving the things around. So why does this... Wait, what? Oh, it's because I did not change the priority here. Let's say 6.2 here. So this is not going to parse. Wait, what? It parses everything. Wait, what? Hold on. Didn't I just try this earlier and it did not work? I parsed my entire thing. Okay. Maybe that's what I need to do then. Okay. So we can say that let X, which is like T into T, is X into X, right? And this should be parsed properly. X 1 to X hello is hello, right? X string hello. Okay. Type of X, type of X. What about the type of? I feel like I did not also like the priority of the type of operator. If I say type of, like if you do C++, for example, right? Type of. Oh, in C++ you require parentheses here. Yeah, whatever. C++ mentioned. I don't like requiring parentheses. I'm trying to like go without it. I'm actually, I think that I'm going to have to go back and use the normal language syntax where you call the functions like over here, right? I call the so X, this is over here, is a generic function, right? And I call it with argument hello, right? And I did not use parentheses here. I feel like I will have to go back for certain reasons to require parentheses. And I think the reason is methods. So like, because when you have something like this, you know, you have like object and then you have like dot method a. So you have dot method like, and then you have dot method, right? Let's say that this argument is a and this argument is b, right? If we don't require parentheses here, then how does this look? Then it looks like this, right? Which means that it looks like I'm trying to call this method with this being the argument, which is wrong, right? That's not what we're trying to do. But normally these languages which just allow function calls without parentheses, ML-like, they don't have methods, I guess. We do have like the pipes, right? So we have like, instead of that, we say like this. Method A, method B. But the reason I still want methods is because this gives you namespacing, and this is like a not a top level function. This is a function that belongs to the type of the object that you're trying to call the method on. Namespacing is good, right? Demo is looking cool. Did he write her own game engine? Yes. This game is written in Rust in a custom game engine. You should wishlist it. And there's a demo that you can play. Did he write code directly to Vulkan or DirectX? It's using OpenGL. I use OpenGL. I use WebGL in case I'm compiling to WebAssembly, because that also works on the web. Or I'm using very old OpenGL, OpenGL 3.3 or OpenGL ES2 or WebGL 1. So I don't really know all of these like modern hardware like things with Vulkan and even the modern OpenGL, like the geometry shaders, like whatever compute shaders. I never write this. We just have like vertex and fragment shaders, and that's it. There's this new thing which was recently published called No Graphics API. Do you guys see that? The graphics APIs are like very complex, these modern ones, like and stuff. Do you guys see this? This person is a well-known person in graphic programming, I guess. They propose some simpler API instead of all of your Vulkans and stuff. So I guess this means that a new API is going to emerge soon, right? You didn't understand the point? The point is that everything is overly complex and we need something that is less complex, right? Because, yes. I don't really like I said, I don't really work with these like things. Because I'll only work with old OpenGL, but it still looks very complex. Surely that API will unify everything, Copium. Yeah, I don't have like enough experience in Vulkans and metals and DirectX 12s and stuff to actually comment on how good that article is. But yeah, the wrappers for everything will end in performance issues. Well, that's supposed to not be a wrapper, right? But a new API, right? And you can write a translation layer, similarly to how Vulkan can work over metal, for example, right? Which has performance issues because it's a wrapper, right? Because you don't write metal directly in that case, or whatever. Anyway, what I have a little bit more experience with is programming languages. So all programming languages suck, just like all of the graphics APIs, and we need something that actually doesn't suck. So that's why we're making a programming language. By the way, Koopman, I'm thinking that over... Infinite Coder. How are you doing? I'm thinking that over my Christmas I'll write C include for a camel. Do you think you will use it? I want to literally include C header files and you would have auto-binded functions available. You mean like you have a preprocessor which parses like C headers and generates the bindings automatically for you? Is that the idea? Like BindGen in Rust? Yeah. I don't know. I don't think I will use it because I plan to self-host the language relatively soon. And I want to get all out of OCaml. I don't like it. But yeah, that's a good idea to do something, I guess. Yeah. All right, let's see. So everything works. Everything that I wanted to work works. So we have better syntax than before. It's not good, but it's better than before, I guess, right? Maybe. And we are back to like monads and stuff, the higher kinded types. So here we go. Here we go. We are trying to see if my language can do higher kinded types. So we start with a functor. If you ask me what a functor is, I have no idea. What's a functor? I know how to write it. It's a design pattern inspired by the definition from the category theory that allows one to apply a function to values inside of a generic type without changing the structure of the generic type, right? So if you want to like write, what's like a good example that like a normal programmer would understand though? That's the thing that I need to like come up with. I don't like working with pure math or whatever. Anyone has a good example where the higher kind of types are usable? I think something like maybe something like traversable is useful. Functor is almost like a container, yeah. And traversable is similar to functor, right? Like it basically declares an interface that we have a data structure that we can traverse, right? Fold. Yeah. Yeah, so functor is a container. Traversable is foldable. So traversable is something that's a functor and foldable, and it's traversable, right? But if we are talking like we don't know math, then traversable is just like a generic collection, right? So if we look to something like C#, C# has an interface iCollection, maybe, right? There we go. Isn't that the traversable, basically? So C# doesn't really have higher kind of types, right? And it can still do that, right? Or is this also considered a higher kind of types? It's a collection of T's. Yeah, that's not really like that. We have traverse sequence map M. Is traversable a Haskell like into iter in Rust? Yeah, I guess. I mean, I think it's foldable though. Foldable is the into iter, right? Foldable represent data structures that can be reduced to a summary, a value. But I mean, this is basically, so in Rust there is like the collect method, for example, or whatever. Foldable. Fold monoid M, T M into M. Wait, what? How do you implement that example? So if you fold this, then you do this. This is like flattening the the list of lists. If you fold the tree, then you get this sum of things. I feel like there can be like multiple implementations of the fold though. Why is this a type class? Right? Isn't there multiple implementations of fold for a collection? Like you can, for example, you can implement foldable as the sum, or you can implement foldable as the multiplication of all of the elements, right? Cool thing about traversable is that you have a list of IO and you have sequence, and you can sequence it into IO of list. Is that about traversable, or is that about lifting the monads though? It's about traversable. So if we have a traversable, T type, right? So it's so we can traverse like integers, right? In our type that implements this interface. Traverse, applicative F. Toot. FTB. Traverse. I see. So like this is, yeah, this over here is basically like a monad, right? Wait, what's the difference between map M and traverse? Is it the only difference that this is a monad and this is applicative? Why is this different? Isn't this the same thing? Map each element of a structure to a monadic action, evaluate those actions from left to right, which is basically traversing, right? Is that different? Map each element to a structure to an action, evaluate those actions from left to right, and collect the result. This literally, like, even the description is the same. Why are there two functions? Because not every applicative is a monad. Yeah, but every monad is applicative. So why is this exist if there exists the traverse, right? Because monad is something that is already applicative, right? Why is there a need for two functions that are doing the same? It's just a historical mistake? Okay. Hello, C program lover. You don't really understand the difference between foldable and traversable? Yeah, like, and like in order to fold, you map every element to an action, and then you collect the results. So in order to, and then like, well, I guess the way you collect the results is in this case implemented in the applicative itself, right? This thing knows how to collect the results. But in case of a foldable, it's the data structure itself that already knows it, because it doesn't require a different thing. Is that the difference? Right? Well, I mean, no, but fold is still a monoid M, right? Which describes the operation. Yeah, in this case, this is a monoid, which is not necessarily the applicative, right? Okay, I mean, yeah, but every applicative is a monoid, is it not? Functor? Oh, maybe not. But isn't a monad a monoid in the category of the n functors or whatever? Wait, hold on. A monad. A monad is not monoid in Haskell? No? Why not? Functor applicative monad proposal. Haskell calls a couple of historical accidents on its own. while some of them, such as the number classes hierarchy, can be justified pragmatism or lack of strictly better suggestion. The proposal contends the list of changes as follows. Applicatives becomes a superclass of monad and is added to the prelude. Isn't that already the case? Because monad means that it also is applicative. Is that already the case? This is base 420. Or is this the the implemented proposal? Alternative members become superclass of monad plus. Monoid are special. Why is it special? And hold on. Why is monad not a monoid? Haskell. It's like a monoid on the type level. What am I? There are different algebraic concepts in Haskell. A monoid is the empty one and append, right? But a monad, this is over here is, yeah, we don't have the identity element in the monoid, right? In the monad, or what? Yeah, what would be the identity? Empty is pure and append is bind. Pure is the identity. Oh, because like this is the end functor, which is identity, right? Which is not doing anything with this, right? That's what it means. And this is the operation. I mean, yeah, sure, whatever. Let's forget about it. Let's do something else. Hold on. Let's just see. I will just, yeah. Let's try not get into this. Let's go the other direction, right? I'm trying to have something that is understandable by a normal human instead. I want to like have a better example. What's a good example for HKT that is understandable without PhD? When your favorite streamer goes from being programmer to being a math streamer. Without needing PhD. Types that takes out types as parameters, not just values. So box T is this. Type constructors, like it's still starting with a functor. Is it always starts with a functor? Can we not say functor out loud or something? Mappable container. Yeah, I don't know. Fine, we just say functor. Okay. I don't know. Why is it so difficult to come up with like examples? Replace functor with burrito. Okay, so we have functor, right? This over here. I want to say that. That's the type of f here, right? Type into type. Now we do that. We implement option as functor and list as functor. Replace all. Right? Transform. Like we are basically, so we say what a functor is, and now we want to write a generic algorithm that is doing that, right? Fmap. So my functions right now, they can be effectful. So we can actually implement, for example, the sum, right? we can implement like some. We can implement some if we have a functor, right? Impl option T as burrito sounds kind of cool. Some we have like let's call it A. A is f of integers, right? And we want to just calculate the sum of all of the integers inside of this functor, right? That's a thing that we can do. So we cannot do that in Haskell because the things are pure. But we can do some impurity here still. So we will just say f as functor dot fmap. Well, fmap is like returning the new functor, right? Which is why we actually just want traversable, right? Maybe let's just call like iterable, maybe. Right? That's the thing that we want. But why do any higher kind of types for this then, right? That's the question. Because we shall just implement that like generically then instead. Impurity really in front of my waffle? Well, we're supposed to have like effect system in the language. We just don't have it yet. It's pure in the sense where the effects are under control. Eventually, they're not right now though. Right? Like if you have a language like won't have a language which has both like higher kind of types and effects. Is Flix one of those languages? Where is the higher kind of types? Flix HKT. Modality when? Flix supports higher kind of types since traits can abstract over type constructors. For example, we can write a trait that captures iteration over any collection of the shape TA, where T is a type constructor of type, and A is the element of type kind. So we have trait for each. For each is implemented on the type constructor, not on the constructed type, right? Maybe like this is easier to understand. Like, but the issue is like we implement for each for option, right? What you do in other languages like Rust, you instead say that you have a generic instance for each, for every option T, where T is any type, right? And that doesn't need higher kind of types then, right? So this example is not very convincing that it's necessary, right? So what's a good example of HKTs? Well, that's the problem. Or can they not have like generic instances? Maybe that's how we make it so that we never need to have generic instances, because I don't support that right now anyway. Maybe it means that I don't need to support it, because then I just need to implement traits for the type constructors, not for concrete types. Higher kind of types versus associated types. For example, as we can see, we can we can define for each trait in two different ways, with a hierarchy types or with associated type. Trait for each t, type element for each f, for each element t into unit with effect xt. So t in this case is the concrete type, right? In case of for each, the definition with the associated type is more flexible, since when it can implement an instance for string with associated element char, right? Yeah, because like we can iterate over strings, right? And string is not a hierarchy type. However, hierarchy types are still useful. For example, the Flix standard library defines the functor trait as this. And how is this useful? Okay, I mean, sure, but how is this useful? Because we need to map, right? Okay. I guess functor is like the only example that makes sense when to map, but it means that sum is not what we want. But what is a good example of usage of a functor? What's the simplest? How do you use it? What's the example of using a functor of algorithm using a functor or whatever, right? Increment all. Transform plus 1x. I mean, yeah. Sure, increment all. I have replace all, which is the same thing. Increment all maybe is more useful usually, right? Okay, let's rename this increment all, right? So we are working generically with any type of container which contains integer. So I'm going to not say AB. We have a functor, so we have a container of integers, and we incremented by integer, right? And this is going to return the new container of integers, right? So fmap a element to element plus x, right? That's how we do it. So we have an option t, which is sum1 to 3. We increment all options. I mean, let's even make it easier, right? Let's just say that this is just that, and we just say plus equal 1, plus 1, you know, increment. We just add 1. So we have sum1 opt inct incremented, you know. Let's print the old and the new version too, right? Past examples monad. Oh, it's because examples hkt monad now, right? Could not find type function. Oh, because it's not a monad, this is a functor. Okay, there we go. So we have the sum1 and we incremented it. We got sum2, right? Now we want to do the same with the lists, right? We want to do the same with the lists. So we have this generic function that works for any functor. So we have list of integers, which is list create. I guess I must do it one by one right now. And lists are backed up by trips currently, so I cannot print them easily. But it's okay. We need to actually implement arrays as like built-in thing, finally. Push back, list 1. Let's say, so we have a list which contains 1, 2, and 3, right? And then we say that list incremented is increment all list, and then with dbg print list incremented. Is that going to work? Is it going to infer it? In this case, I was actually specifying the type here of the option, right? But this can be inferred properly, right? Or can it not? Maybe it cannot. Blocked value shape. T is not equal to T. Okay, we have some issue of the inference. Okay. Now we go back to fixing the bugs. So, I mean, technically, this was printed properly. So just say here list to string, list to string, list incremented. I don't have a list to string though. To string t a list t string. I do have it on the trip though. We'll just say trip to string. I think in this case we can use that function. TT the string is not equal. Wait, is this not inferred to be a generic one? Weird. Is a type alias just a type level function? Yeah, I guess. That's why I have the difference between the types and the new types, right? If this returns a type, then it's a type alias, and if it returns a new type, then this is creating the new type. That's the difference, yeah. And they are both just functions. No implementation of type T as std to string. Okay, this does not work. Let's give it like f, which is T into string, and then I just do that. I just give it f here, which means that my toString needs to know how to print x. To I just say toString. This toString. Probably can. Like toString int32 basically, which is the same thing. Wait, what? No? Oh, yeah. Because that takes a reference. Makes sense. X toString x. That works. Okay, incremented list is 234. There we go. Okay, and now we have some issues. What is this? Cannot find string in scope. Wait, what? Is this like trying to use the old version of the code? Yeah, it's just say blocked value shape. T is not equal to T. T is not T. This is in iterating. Okay. That's in the trip. Okay. It seems like the code technically works, but I have a couple compilation issues, which means that I have a bug. So let's try to rename this T to tjoin. T is not equal to tjoin. Update data T. I don't know. What do we call here? Join. Tjoin. Left data. Update data. T update. That's not the one. Let's see. There's a bunch of T's here. T data. TT. Which one of the T's is there? Not one of those. Create maybe. T create. T singleton. Length. T NSB or whatever. T S. Not one of these. Split. T split. It's T split, right? No, it's not. T split at. There's no way. Which one of the T's? The at? It's not at. Set it updated to string. To string. T to string. T to string is not equal to T over here. Iterate. Trip. T iterate. Has it been used in the list? T list to string. Maybe that's one. No. It would be nice if I could like click on this symbol. Is there a way to do that? Like this is the T, right? I want to be able to go to the definition of this T which I see in my error, right? Without seeing this pen. Is there a possibility to do that actually? Maybe. Can I annotate terminal output in VS Code so that I can click something and it takes me to source code? Yes, you can. VS Code supports clickable file links in the terminal. You just need to format your output in a way to recognize. Here's how it works. Yeah, but I don't want to see it. I want clickable links that take you to the source, but I don't want to see the ugly path text clutter in the terminal. There is a neat trick for that: ANSI escape codes. VS Code terminal supports hidden links via OSC 8 escape sequence. You can make a piece of text display as whatever you want, even nothing, but still be clickable. All right. Did you guys know that this is possible? Can like other editors do that? It's not only VS Code specific, right? The first this starts the link and the second one closes it. You can put any text in the middle or nothing at all. This gives you a clickable hotspot in the terminal that jumps to file without showing a giant path. All right, this is huge. I should use it. And what happens like in the other places? Like if I do this inside of the actual terminal, is this escape code going to be ignored in this case? Invisible but clickable. It's a terminal thing, not a VS Code thing. So, okay. So that's not specific to VS Code. That's like the general thing. Okay, nice. So this is what we need to do, right? Or a small emoji if you want a dot to click. This is invisible. Yeah, I don't want it to be invisible, right? I want this. Let's figure it out. So I want to say T over here. That's nice. We go to printing. We go to printing. Right, and we have print binding. That's what I need. Print binding. So we just print the symbol, but we have the actual definition for the bindings, right? Bindings. We have labels which can have a definition, which is an optional span. Get data span. I can do this one. I can just have get span here. Okay, data span. It gives you the definition, and if the definition is not found, then it just gets the first reference. So we can actually like go somewhere still, right? So yeah, that's what we do. Let's see. Let span be binding label get span. Okay. Is this how you escape this in OCaml 2? So this over here is going to be span, and this over here is going to be the symbol itself, right? Span print span. There's no way it's just going to work. Is it going to highlight it in the thing too? Oh, it actually highlights it. It says opening URI can be insecure. Do you want to allow opening links with this scheme? Wait. Can I like highlight this? Like it gives me that, right? Should it say file? Maybe. Maybe it should say file, but it's only giving me the path without specifying that it's a file. And that's why it complains. Like, why do I need to give it permission? Although that's like the span. Span is already like just printing the URI, right? And the URI, but when you print in the URI, if it's file, then you can omit it, right? Or is that not the case? Or do I not have the file there for some reason? Which is weird. URI print. Oh, yeah, I literally do this. If it is a file, then I don't print it. Should I always do that? Like, yeah, I also want to like print the file if it's a relative one. I guess. OCH requires file. Yeah, because like when I'm doing this over here, right, I can click, right, and this does not say file. I also want this file, this path to be like relative, so I want like two ways to print my URIs anyway. I want to print, which is like going to print it relative to the current working directory, I guess, for simplifying, and print the full URI. Let's say over here print full. I mean, yeah, we just do this one, right? Is there a sudo? Okay, so this is yeah, and I need to use it now when I'm printing in the escape codes into. So I need to like span print. Print. Maybe I just need to like print OSC8 or whatever. That's what I call it, OSC8, which is going to include the escape code then. How about that? Which means that this is also having the function as an argument of how to print the value, right? Which is so this also has formatter a unit and a now it's weird. How do I want to use it? I want to like say something like print percent %a, and then we like print OSC8 which I mean I guess then I do the T and then I print OSC8, which is like span and like the value that I'm printing, and then I need to like specify how to print the value like this. Is that how I use it then? So this is going to be like span into a into formatter a unit a formatter like that, right? Print full URI is a separate one. We just use this print full on the URI. And print OSC8 is going to be that. So we have span, print value, and FMT. Span is span, right? So we just fprintf that. That thing where we print full URI span, and then we print value, right? That makes sense. So print binding is going to be span print OSC8. So we have span, and then we have symbol print binding name FMT, right? That's literally it. Okay, I think that's nice. So I can like do these annotations in other places too then, right? Okay. Okay, so T, it's not clickable. Wait, this is always a link. OSCAs is always a link. It cannot take a range. Maybe that's like because it was sparse. Like this colon here is not making sense, right? Ah shit. OSC8. Wait, but no, they do say like file this colon. Maybe they don't support ranges. They only support the positions. Like this is a correct one, right? Like I can click it over here. I can click it if it is in and as text. Okay. They don't support positions because a file name would also contain columns. Can a file name contain columns? So ChatGPT is wrong here, right? Because ChatGPT gave me the example which does this. I mean, I'm doing not just the position. I'm doing a span, which is 2 positions, and this is a little bit more complex, maybe. So I can like only print start or something. Can I like print with the function that prints the URI formatter, URI unit, you know? So this should be like print URI then, and this is like print URI. And then I say something like that: print is print with URI print. And then print full URI. So I don't need to print full URI like this. It's not necessary. So this should be like print with print span. On Linux, files can contain anything except slash and null. Yes, but what about the URIs though, right? Because the positions is not part of the specification of what a URI is, right? Or is it? Because that's an extension, right? What I'm using here, this format is called like, I forget this what the name of this is. Like GNU spans maybe. I don't remember what it's called, but like, yeah, maybe this one is not supported. Let's just try to say that print span is no print width. Okay, hold on. We have a URI print, and then we also have this span print. We have a full custom thing, I feel like, in this case, actually. Not even print width. Let's say print span. Print span. Print URI is going to be URI print full. Start line, start column. So like let's first try to do this without the positions at all. Right? Without positions at all. Can I do that? So yeah, this definitely goes to this file. We go to different files. One of them is from the list file, one of them is from the trip file, yes. But, okay. So can I print the position now? So it is a dot here. Maybe this is the problem, right? Because that's a different format than this example, actually, that ChatGPT told me, right? It's file line colon. But what I have is I have like line dot column and then dash line dot column, which is a different format, right? So this is going to be just start line and start column. And it's not clickable anymore. Okay. Are you sure we can include position in OSC 8? Yes, but not in the way you might hope. The OSC 8 escape sequence itself does not understand line or column information. It only encodes a URL. VS Code plus file URLs with positions separately, so the trick is to encode the file plus line column in a file URL, which is this. So how it works: file colon line column, file line column. The URL part includes the line and column. VS Code detects the URL. My VS Code doesn't detect such URL if I include a line column. What the fuck? VS Code does not parse line column inside file URLs in OSC links. It only recognizes file column when they appear in plain text in the GNU span format. Yes, like this. If you try this, treat the whole thing as a URL, just a clickable jump to the line column doesn't work. VS Code only jumps when it parses from the text content, not from the URL. Is there an issue in VS Code? Is there an open issue about it or something? All right, so now I just waited like half an hour on this, trying to make it work, and then VS Code doesn't actually support that. Support hyperlinks to specific file line numbers in the terminal. OSC. There is nothing about the OSC here. That's the wrong issue. Support hyperlinks in specific file numbers. No. OSC 8. There is nothing about OSC 8. Is that what it's called even? Where's the specification? OSC 8 adoption. Hyperlinks, aka HTML-like anchors in terminal emulators. Most of the terminal emulators also detect when a URL appears on screen. It was, however, not possible until now for arbitrary text. Is this like new? 4 days ago? That's when it was last active though. The escape sequence. You have OSC8 semicolon params semicolon URI. Maybe params. Params is an optional list of key value assignments separated by the colon character. Relatively new as far as terminals are concerned. Well, I mean, I can go to the file, right? It's just I cannot give it the line and column number. Do they specify this here? File URIs and the host name, web browsers, this, that. Detection availability, length, limits, encoding, security. There's nothing about position or span in this document. Right? Which means that this doesn't support it at all. But that information is not enough then. Well, I mean, there are these parameters. I feel like I should be able to use the parameters. What are the parameters? Params is an optional list of key value assignments separated by column character. Example, ID is this, right? Can I just say like line is this, column is that? Or like span is this? I mean, but the what parameters are actually recognized by the VS Code is dependent on the VS Code then. Is that part of parsing OSC 8 like open source in VS Code? We're going to like look at the source code, because even like looking up the fact that I can like highlight the span and not just position was not very easy when I did this. The GNU span format, it's also not really documented anywhere. See below for host name. Host name. File URIs and the host name. Web browsers and stuff. If you SSH. Oh, because files can include the hosts? Hostname component should contain a fully qualified hostname. Hover underlying and the ID parameter. Maybe terminal automatically recognize the web addresses that appear on the screen. So yeah, like ID is how you like go to the web page and to the specific element on the in the HTML, right? What I want is to go to a specific line and column. There, like I need to have the parameter. I'm pretty sure. Maybe I can encode position as OSC 8 parameters. That won't work with VS Code. Param, URI, val, text, escape. Usually for ID or custom metadata is some terminals. VS Code terminal only looks at the URI. What actually VS Code actually supports? I mean, it keeps insisting on this is supported, but it's not supported. I could implement the feature yourself in VS Code by like writing an extension. Yeah. Am I going to write the extension so that just it's easier to debug my type errors? Right? That's the reason. To implement an extension for VS Code. What about like other editors though? Like, what about other editors? Like NeoVim. Sounds like a good rabbit hole. Well, I mean, I already have the extension, but maybe this is not very difficult. Terminal hyperlink support in NeoVim. NeoVim's built-in terminal supports OSC 8 hyperlinks, so you can make clickable links using the same escape sequence. However, like VS Code, via NeoVim itself doesn't interpret line column from the URL. So we can go to file and we cannot go to the position. But it does parse it from the plain text. Typically using regex. So, I mean, for the NeoVim, it will also require a plugin, right? Can I have a look at my code? How do I generate vector 2 noise values for like terrain? Using Perlin noise, I guess. Usually. That's how it's done, I think. Should just search up Perlin noise and then I just use the library for noise. I don't know what language you're writing. Or you can copy paste some existing code which generates the noise, I guess. And then you want to probably combine multiple layers of noises so that the terrain is more interesting and stuff. There are probably articles about that. There's probably a bunch of articles about that on the internet. You want to search for Perl in noise. C++, for example. Here's the header-only library for C++. But when I use noise, get noise, it doesn't work for me. Well, I mean, now that depends on the language that you're using and the library that you're using and how you're using it. I just want to like make sure. What if I like VS Code source code? Is the source code of VS Code actually in this repository? OSC8. You know what? I think ChatGPT can actually point me to this properly. Can you point me to source in VS Code which parses OSC8? VS Code has explicit logic that scans the terminal buffer for things like pathline column. This person somehow has a working link with a number working, but I don't know. Enable OSC8 hyperlinks for line numbers highlighted. Okay, so like this person opened the NeoVim, a line column. I think the reason is that maybe, hold on. Maybe if we do something, shit. All right. Test txt. If I do NeoVim test txt 2, 3. No, that doesn't work, right? File. That doesn't work, right? Oh, wait, hold on. It's because... No, it is test.txt. Here, right? So like this file... Wait, no, what? It's not the file. I cannot give the URI to the thing. So how does the terminal even open that then? That's the question. Like, what is the command to open the file? Some terminals and editors do support file column URL with line numbers, but unfortunately there is no standard. ripgrep support is currently top class. Here's how to find options for file URLs. Is it using the parameters? VS Code :/ file path line column. That's a ripgrep. Ripgrep is the terminal, like, is the CLI tool. Hyperlink pattern aliases. So why is it like have that logic? I don't get it. MacVim, VS Codium, VS Code, VS Code Insiders. It's like what to open the file with or something. I don't understand where is this used. Like, what I want to know is, how does this work here? Let's try to go to projects, cast cast, right? And then with like cast do this, which is going to do that. There we go. So like we see this. The alacrity determines what this is. When I click it though, it doesn't open anything. My alacrity doesn't open this link. It detects it, but it doesn't click it. Do you think I should try printing here VS Code? Alacrity OSC 8. Like, why doesn't it open anything? This is the adoption. Testing support. To determine your terminal, do this. So, I mean, this is going to open the browser, right? Is it depending on the editor, maybe? Like, maybe I don't have editor. Editor is new Vim, right? Pager. Like, shouldn't this open one of these anyway? Or what does it open? Since 0.11. Escape sequence to set hyperlink. They added that, but how does that work? Seems like my alacrity detects OSC 8, but when I click, nothing happens. Do you think XDG open? Yeah, maybe XDG open. Launcher, XDG open. Is that the default? So you are saying that if I do XDG open here, this file does not exist. This file exists. Okay. So, oh wait, it's opened in VS Code. Okay, this is opened in VS Code. Okay. Because that's what my XDG open is doing, right? So if I move this here and then I open, then we see it opens here actually. Yes. Okay. That's what's happening. And then if I say txt colon 10. So now this is a URI that is not supported, right? But how do they detect? Like, I guess it depends on like this person's terminal and how does this do it, right? Because XDG open does not work with that anyway, right? Because this issue is from the XDG open itself, not from VS Code that the file doesn't exist, right? Because XDG open opens the file based on the MIME type of this file, right? So it's trying to figure out what's the MIME type here. So it's not XDG open then, for them, I'm assuming. Or at least like, there are some other arguments here, maybe. Like, yeah. How does this work? Why am I looking into this rabbit hole? How long have I been looking into this already? If I make it work though, this is like huge. I really like if that is possible. The other alternative, I guess, that I have, the other alternative is instead of printing to the terminal, I can generate HTML file, open HTML file, and then I click the link there. Right? So instead of trying to launch my code from within the terminal, and do something like that. You just write your own editor. That's another option, I guess. Write my own operating system, editor, programming language, game engine. This is the way, of course. I write to support this request. I would be happy with the file name in the header being an OSC8 hyperlink. This would also serve as a test case to the suggested line number feature, and the usual file scheme would do the job. Oh, this is the issue of bat. This is bat. This is so that when you like batch the file, you can click the line numbers. That's the idea. And so you're saying that rib grab. Oh, okay. So rib grab, the output of rib grab is you are saying that the rib grab can already do that? Hold on a second. Can I RG? Can I click this? No. Hyperlink format. Set the format of the hyperlinks to use when printing results. Hyperlinks make certain elements of RibGrab output, such as this. This generally only works in terminal emulators that support OSC8 hyperlinks. For example, the output is this. Alternative format string. Okay, so yeah, so we just say VS Code here, right? Okay. Okay, I see. So like there's multiple things that are detected by different editors differently, right? That's what they do. Okay, so yeah, I guess I can do something like that. Hyperlink format is VS Code, right? And then I can click this. Yeah, so this says VS Code, file, home, Kubernetes, like, and then this stuff. And then I actually like click this. An external application wants to open this in code. Do you want to open this file or folder? Well, I mean, if I do this from within VS Code, it should be fine though, right? Let's try that. If I go like to temp address. And if I click that, I mean, I can just click allow, right? I guess. Okay, it actually works here then. Three, 7. Okay, nice. Okay. So this is the link that we need to do. VS Code and then file and then the full file path, right? Okay, let's do that. Figured it out. I'm going to do only VS Code for now, and then later I can make it customizable if someone else wants to use it for some reason. File / VS Code // But this is not print full then, right? This is just print path in this case, right? So it is just print then. Because it's like file. Which means that this also must be like absolute path. But I think it is right now, right? And maybe we can actually do the range too in this case. What if I can do the range? Path does not exist. The path, a list, the path, home projects, okay. I mean, this home is already like being inferred here. I think it means that this is not the correct format. Oh, because this must be dot, actually. That was not the correct format. H20, so like maybe still doesn't support the ranges. No finish. And this works. Clap. Like, I mean, ideally, it would be the full range. So the range basically also automatically selects like the entire range in the editor, not just goes to the position. But yeah, this is nice. Maybe I don't like maybe this also we can get rid of this instead of saying that the error is happening over there. I just like do that because this is just noise. I don't need it if I can click the things, you know. That's probably okay though, if someone else tries to use the language. Okay, let's do that. Source. Print. Camel showing me errors that don't exist again. Nice. Print bindings with OSC8. VS Code only, I guess. For now. Okay. Okay, back to what we were working on. What I was working on, I already forgot. I'm trying to do, yeah, I mean, technically we just have a bug right now, right? So it says that this file, this T, so when I'm trying to do pushback, we have a T, and this T is not equal to T join, right? Because over here, when I'm doing pushback, I'm doing the join, which is this thing. Right, which is this thing, which has that. Okay. And the problem is because when I'm joining, there is something wrong with the inference here. I already fixed the bug like this yesterday. So the problem is, what is the type of this? The type of this is that. But since this is a generic function, I instantiate this tjoin using T from over here, right? And then some of the types, some of the things, they are not being substituted is what's happening, I think. Why not? Why not? The inference error happens over here. It does not say like when compiling something, right? In order to know when compiling something, I need to actually stop on error here. This is going to give me the stack trace. And the stack trace in cast code 2, I think, right? Because when I was evaluating this instantiation, I'm evaluating it, which means that it's at runtime and not at compile time. While evaluating apply expression. Why am I evaluating this? Wait, is this during compilation? Or during... Yes, it is during runtime actually. It is during runtime that something doesn't work. Okay. So I actually instantiate this. I actually instantiate this when trying to evaluate this. I'm trying to evaluate that. I'm trying to evaluate all of this, right? I'm doing this and I'm coming here from the list, push back, right? Yeah. I'm applying that. I'm going here. Okay. So what happens when I instantiate a generic? That's the thing. I feel like at runtime instantiations, like the problem is that there's no distinction between runtime and compile time. But we're doing some inference at runtime right now, right? That's what's happening. Because when I instantiate this, what do we get as a result, right? Well, we get a function. Oh, wait, maybe it's because I actually have no... Wait, hold on a second. If that's the case. Interpreter core. Because I still have like sub mode none sometimes, right? Because when I call a function, I don't substitute anything. What if I still do the full substitution though? I'm just wondering if this is going to fix it. It is not fixing it. It is not fixing it. So that's not the problem. I mean, yeah, substitution only needs to happen when I'm calling generics currently. Let's go back to none. All right, so I instantiate. Maybe let's take a look at the OCaml stack trace too here. We are inside of this instantiate, and we do expect here somewhere. I guess placeholder expect inferred as this. Is that right? Why am I doing inference when instantiating generics? Well, that's because we instantiate them lazily, because we might not be able to do that inside of a fork. Result expect inferred as span. Can I like surround these? Try with inference error. EK. This is an effect. What is E? I mean, this is already been printed or what? No, error is error, which is a message, and span. Inference error print E. Print, E println. let's just do that. And then like fail. Is this the one? That's the one. Okay. So we'll calculate the result. Let's do in this case. Let's do in this case over here. Result is this. Actual result is this. Value print result. Value print actual result. Okay, result is underscore and actual result is this function, which by the way is very weird. Because like these are all not inferred, right? But it means that, okay, yes, but once the result is inferred, then like there might be some further unification happening, right? Is the idea. My error messages are bad right now. Push back, push back, push back. That's all the thing, right? So the result of that, so this is the instantiation of a generic function, and the result of instantiating is a function sorry, which sounds like this is correct. So, but then it tries to unify it with something else for some reason. Why? Would something be happening here? This is the correct type. It has T's. It doesn't have T joins, right? It does not have T joins. And like add more login. Like the issue here is that my compiler is async. The fact that we like unify this here might lead to something else, right? Let's do something like in inference. You know, once inferred. Run once inferred is if needed is like that, right? If not apps list is empty, then I want to like print running once inferred. Let's see if something runs here. Actually, nothing runs here, which means that this was not blocked by no one was blocking for this to be merged. Is it? Wait, hold on. Actual result is a function. Like, what is actually happening? If this is a not inferred value, is it because the type of it? Oh, wait. Is it because of the type? Let's take a look. I'm going to remove this line. What if in the interpreter result, right? I want to know the result. I want to know the type, right? Which is type print type of result, you know, like this. Type of result, and this is that, which is type print actual result type, which is the type of, it's the same thing. Right, so result that I expect is this thing which has t joins. Yes. Aha. Why do I expect the result to be this type? That's the question. Because what is the type that I infer, right? This is new not inferred of type result type. Yes. Result type is not substituted here. That's the problem. Oh, yes. We need to substitute this. Instantiate, and what is the result type? Let's see when we call this function. Evaluate expression, instantiate generic, right? The result type is expression data type, and this is not correct. And this is not correct. What about this instantiation? Is this one being used? And result type in this case is blocked type. This contains in the value. If this contains in the value, then this should, I think, be correct. I think this one is correct. So this is the only place that I need. This is the result type. I need to know it properly. Let result type be... Yes, and what is it? And what is it? It's substitute bindings, substitute type, expression data type, state, and span. Now it says that int32 is not equal to t. We have made progress. We have a different error. So now we don't have the problem that t is not equal to t, right? But the problem is probably the fact that t is equal to int32 in this case, right? So we are trying to evaluate this over here, and t join in this case. So the t, the type that we're storing inside of a trip, is an integer. Indeed, it is not t. It is indeed not t. So even this thing is not correct, right? Even this thing is not correct. Result type. Even this thing is not correct. Why not? Because this type is substituted in this scape, in this state, but the expression itself should have had the thing. Because result type should be what? Evaluate expression, instantiate generic. We have the generic, and what is the result type of this generic, right? That's the question. Instantiate, like, is there a thing where we do the inference here? If the type of a generic is inferred properly, then we can infer the type of the result. Why do I even need result type? That's another question. This is like hurting performance too. Not that I care about it. So the reason this is not enough, because a substitution must happen like in multiple places. This expression data type is the type that's inferred only in the original, during the original compilation. So result type should be done not using the type inference here, but using like my concrete values here instead. We have the value of the generic, we have the value of the argument. What is the result type? Maybe I need to... Maybe all that I need to do is to say that result type is like, how about we just remove this? If I remove this, is going to do anything? You know, because result type can be an optional one, maybe. Okay. Yeah, so okay, hold on. I see this. So we have when we instantiate the generic, if the generic itself is a blocked value, then we have this thing which is blocked by that, and I store the type, which is the result type. But isn't result type just result.type here, right? Value instantiate. It's an optional one. Okay. Now we say that the variable over here, increment all, is not inferred. So now we cannot run this because the inference doesn't work. And the inference doesn't work because this over here has the thing, the variable, right? This is the variable that is not inferred. No, wait, the variable is not inferred, which is the result of instantiation here. And that's not inferred because this is not inferred, right? See over here, option T. Is that going to be inferred? Yes, that is inferred. So like now this cannot infer the monad that is used here. Okay. Or the functor. And it could do that previously. But now it cannot. So I actually want to be able to infer the type here, right? Yeah, because the type is now not stored at all. Okay, how do I figure out the concrete type that is needed in this position? So like I'm trying to evaluate the expression, but the expression is like a part of expression that was substituted previously. And I didn't do that. So like the actual problem is something like this. We have we have a problem like this. When I have a function, t function dbg print t, right? Not dbg print t. Let x t be underscore dbg print type of x f. There you go. This already is incorrect. This is already incorrect. We see t on the screen, but in this case, the t is some type which is not inferred. Like I can instantiate this explicitly with int32, so we expect this to be int32 here. And this is the bug. So why is that the problem? Because when I instantiate this generic, we don't recompile the function. We still use the original function, and the original function in its compilation is replacing type of x, which with t basically, right? This is going to like similar to basically saying comp time t, I guess. That's the same thing. No, it's not the same thing, kind of like. Because I guess I don't substitute these. I don't substitute the constants inside, and I probably should not. I mean, this is probably also something not like what the programmer expects here anyway, right? We don't expect this to be printing t. We expect this to print int32 if I do that, right? Or do I? I mean, this is comp time. If I just say t here, it is going to print int32 because at compile time we don't know that it is an int32. We only know that it's a t. How do I like make the minimized version of this? To have this thing, let g u does this break something? It doesn't. I mean, because the functions are still unit into unit, right? Can I say like over here 1, 2, 3, where this is going to be x, which is t, and this is x, and like in this case x is u. Now, I might have something that is generic or not. Let's bring back the result type. Result type is data expression data type. This is going to be the error in the t is not equal to t join. over here. Oh no, I now see my things over here. So I should print it only if it's detected by the current like channel or whatever, right? I don't need this in my hovering. T is not equal to T join. Right. Because we have figured out that what I want this to be instantiated into is T join, right? So why do we expect this, the type of this, to have T joins here, right? Because okay, hold on. I think I understand what I can do here. I need to have like a type, a generic type, you know, like foo, which is T, new type, X is T, for example, right? So then I have a generic function f, which like this, let's just call this parameter f, right? And then we just say over here that I have a g f, sure, g f x, g is g x g into foo g, which is x. Is this going to break it? No. What's the type that we expect this to be? GF. Isn't GF in this case expected to be it's expected to be basically f into foo f, right? Right. Yeah, so over here, this is the last substitution that we do, right? F into foo f. Oh, the actual result doesn't know the type. That's why it doesn't break. Wait, okay. So like, okay, why don't I know the type here though? So like I construct a function which I don't know the type of? That makes no sense. If I have a value, then the type should exist, right? Okay. I see some issues here. That's why it works, even though it shouldn't, it seems. So we have a function which I don't know the type of. But I know the type of the function here, it's already inferred. Okay. Actual result is this. It's not because of substitution. It's because of what? It's because actual result. We have a function. Do the function values not have the types or something? There's no way, right? This is a function. of this type when I instantiate this thing over here. And I don't see the type here. Why not? Where should I look? If I have interpreter core, if I have so in the interpreter core, I'm instantiating. I was like wondering if the thing does not have the type even before substitution, right? Because instantiating should say instantiated generic, right? How about this? Evaluated call before sub info. Because that's a function call basically. Okay, so we want the result to be this. Why is there a new line here, by the way? That's weird. Or wait, does the VS Code put the new line here? Because this thing does not fit on the line or whatever. No, that would be weird, right? Maybe I'm printing the new line here for some reason. Anyway, so we have like this. The actual result is that. Evaluated call before sub over here. Yeah, so we have a okay. So there you go. We have a function g into g, right? That's the function. And then we substitute g to be equal to int32. And we get as a result a function from int32 into foo int32. That makes sense, right? We got this. We substitute g with int32 and we got this. Yes. So I'm wondering what is the type here, right? Which is going to be type print result type. The type is g into bug foo type g. Okay, and then so like after substitution, then once again we are going to make this into info. This and the type is that, you know, result type print result type. Let's see here. Yes, after substitution of this, we have correctly substituted the value, but I did not substitute the type of the value, even though before substitution, I knew that the type is g into bug foo type g, which was correct. Okay, so the problem is, why don't we substitute? Because that's a type. Right, when we say substitute value, result is with cache substitute value. When I substitute the value, we substitute the variable unite shape value new not inferred substitute. Okay, there is something, right? Because the value is the thing which has two variables inside. It has two variables inside. substitute variable, unite shape, subshape, new not inferred, get var, and stuff. So I did substitute, right? Using substitute value shape. My value was a function. My value was a type. No, my value was a function. So say function, where we substitute the type of the function. Shaped. Shape is value inferred shape. So this is inferred value. Type is type of value shape, right? Which means that I should know it here. Okay, let's say over here, if I substituted the value, right? Okay, fine. Fine. Let result be this in result. Print sub function into this that value print result type print result type. Let's try that here. I substitute function into this of this type. Okay, hold on a second. Look at this. So I have substituted the function into this type, which was of type int32, into this. But this information is lost somehow. This information is lost somehow. Okay. Why is this information lost? Where is this information lost? Sub value. Sub value. So I substitute variable. We can get the variable. This gives me the value. We have the variable, and I unite the variables. I unite the variables. One of the things that I can do is like this. So I have when I create new not inferred variable value, when I create a new not inferred value, so value is two things. It's the actual value and the type of the value. I keep the type along each value, right? But the thing is, maybe like I infer this variable, and inference of this variable does not result in me inferring this thing. Is the thing. Because these are the only ones that I unify. I don't unify the type here, which means that I basically need to say, so here's what I'm doing, right? we have the new not inferred value. We don't know the type of the value. We don't know the value of the value, you know? So this over here says that if I know the type of the value, then we might know some of the value, right? So for example, if it's a tuple of two things, then we know that it's a tuple of two things. These two things are not inferred still, but we have some information. But we don't have it in the other way, because we need to say this: if variable, if the actual value is inferred, so this is going to be value shape, then we need to basically say that the type, right? I'm going to say unite type span type of value shape. If I know value shape, then I know the type, and this is my actual type. It is applied to too many arguments. Span type of value shape. Value is this thing. Type of value shape type. There we go. That's what we want. I don't like the fact that it's ignored. Let's instead let underscore type is this. Ignoring can be ignoring the or the partially applied functions, which is annoying. Let's see if that fixes it. Okay, so we fixed one bug and we are back to the other bug. Okay, so now we are actually panicking. Why? Because int32 is not equal to f. We have this thing, right? So what's the problem here? We are trying to instantiate this generic gf, right? So what is the type of this? According to, like, during compilation, when we don't evaluate anything, we know that this type is going to be basically f into foo-f, right? But during evaluation, we know the concrete type, which is not f into foo-f, which is because f is already has been substituted with it has the value already, right? Yeah, which is why in the interpreter we have 10. Over here we just substitute binding, substitute type. So we perform the substitution here. If I perform the substitution, then, well, then this example specifically is working. Okay, now I need to see where this other thing was panicking and make another minified example over here. Trip create is not equal. So when I'm instantiating trip create, so that's because I'm calling a function that's calling a function that's calling a function. Right? Yeah. It's because when I okay, so let's say that we have fg And then we have h, right? H is h x h into h into full h, which is x, and g is just calling hg x, right? This still works. Shit. Wait, why does this work? What I need is to perform the substitution in the context where the variable is I'm just going to remove this logging here. Yes, so over here, right? I subbed function into a function that returns t. This is like I still have the binding. Instead of the concrete type here. This t is this t, right? This t is this t. Wait, but that is really weird. Hold on. I substituted that. The inference fails over here. When I evaluate this thing, this instantiation, this is implicit instantiation of a generic, right? Like this. If I do it explicitly, it's still going to not work, right? Wait, hold on a second. Hold on a second, it actually worked. When I do it explicitly. Why? Why does this work? And the other one not works. Okay, fine. Let's try this. So over here, I'm also explicitly calling this, right? Let's try doing this implicitly. Because it's supposed to be inferable here. And this also panics. Okay, nice. I have a simpler example. Do I need to go through the three things, or can I just go to a single function? I can go a single function. Okay. So over here, I instantiate the generic implicitly here. This is also, let's do it half explicit, which is this, right? This is the same thing. So this underscore is the thing that must be inferred, right? And this is inferred to be f, obviously. This is inferred to be f. Oh, because this is a oh, okay. Because what does underscore mean? Underscore is a constant, right? When I evaluate the underscore, I don't substitute. But when I evaluate f, I do substitute, right? Because this thing exists in the scope, and thing is a constant. This basically is the same as saying comp time f, I think. Right? So this is going to also panic very similarly. Yes, okay. Okay. I think I understand. So when I have a constant, the constant might contain the variables inside of it, right? So we have expression constant. There we go. A constant expression. So I just do I just do like substitute bindings, span, state, value. I substitute value. Is that what I do? Really? And it worked? And this actually worked? Which also means that, once again, if I try to do dbg print comp time f, right? This is actually going to print the proper type here, right? Let's remove the logging. Yeah, so the type here is int32, even although at compile time we don't know that it's an int32. This is a constant which refers to a runtime variable. Does that make sense even? Oh my god. But it seems to work. So like, what if I go back to HKTs and functors? Well, now we still panic. Okay, why do I panic? It's probably some other issue though, right? The value cannot be inferred. Okay, I think that's a different issue. So now we have the inference issue that is not something that is inferred incorrectly, but something that is just not inferred. That's a different bug. Expression variable at subst var is this. This happens when I do that equality not equal apply if then if I is not equal to 0. Wait, oh, it doesn't know that this I is an int to string, trip to string. Not equal, like literally this I not equal 0 doesn't work right now. Okay, do I need to say that this is int32 here? Yes, but the reason this is complaining though is also weird. Right? This is also weird because well, maybe it's not weird. Like, where do I need this type to be, right? It depends. Like, I am defaulting to int32s, but this thing is called setup default. And setup default is happening when I await fully inferred value. If it's not inferred right now, in LSP hover, and over here I'm just setting the defaults. So the question is, when is this being used? This is being used when I evaluate expression cast on my implecasters module and do that. But in this case, wait, so what is not inferred exactly? What is not inferred? Is it like in the natives or something? When is it not inferred? I'm evaluating. I'm doing await inferred. Yeah, it is natives. Natives mod CMP. There we go. We'll say in await inferred, right? But since I am trying to like, this is comparison function. This comparison function, I need this to be inferred. In this case, it's an integer that needs to be inferred. But in order to infer the value of the integer, I need to infer the type of it. Can I only compare the things that are fully inferred? I think that would probably make sense. So let's just use await fully inferred. How about that? Can I just say await fully inferred? For both of these. And maybe like that makes sense to do for the operators too then, right? When I'm trying to add the things together, it's an integer, int or a float. Let's just say await fully inferred. Wait. Await fully inferred is not returning the value itself. But it should probably, you know? Because why is it not doing that? Await fully inferred is just doing that. Yeah. This should return value back. Now this is what we do, right? We set up the default and then we just inference var await inferred. I mean, yeah, this is not the correct implementation, but that's what we do try, how we do try it now. If I need this to be inferred, value shape custom module opt let underscore value shape is this. So I just ignore this in these places, but I don't ignore it in that other place. It cannot be awaited. Still the same, not equal. Still in the natives. This cannot be awaited. Why not? Await fully inferred. Oh wait, it's because it's the result of substitution, the type there. The type is not inferred. So when I substitute the things which have defaults, that doesn't work. That doesn't work. Because the substituted value does not have the default. So this doesn't matter that I did this. Unless when I substitute, it also should have the default. I mean, the problem is like, when do I set the defaults, right? Right now, I set them when I actually need the value. The inference with defaults is weird, also. Okay, how about I just annotate it for now, you know? Because I don't know. I feel like the actual solution is that I need to, like, before evaluating anything, I don't know, it's not about anything. Oh, wait, no. Maybe like setting the default should actually be set the default should actually be done through substitution. Hold on a second. So when I have substituted bindings, the problem is that we construct the new variables. Right? We have a sub var. I construct the new variable substituted temp. And substituted temp does not have the default, even although the original variable could have a default. Yeah. So I have setup default. And like similarly to remembering the sub from, maybe I just do it here. So it's like, this is the variable that I substituted from, right? Which means that in this case, I want to remember the setup default function too, right? Yeah, can I just say that? Just say that root dot setup default fine, we make it dismutable. If root setup default is none, then root setup default is from setup default. What if I call this function multiple times? This function should be callable multiple times though, right? I can make sure that this function call is called only once though. Because over here I'm duplicating it, right? Let's say deduped. I mean, let's do over here. Let's do this: match root setup default and from setup default. If it is like, you know, none and some f, then we are going to say that root setup default is some f, right? Like that. If it is any other case, I'm just going to not do anything. Right? But this means that I'm duplicating it. So I want to say both this and from setup default is also some f, but I'm going to say that f is deduped. So f is a function which we say called is ref false, and then I say over here when we call the function we say like if I guess we just do match called with false, then we say called is true, and then we call the original function. But if it's true, then we just don't do anything, right? So we only call it once. And it works. Okay, nice. I like this solution. Okay. So we have a functor. Let's take a look at this code again. What am I running? It looks like it also is running for a couple seconds here. Even though there's almost nothing happening here. The performance is absolutely horrible, I think. With all of the substitutions and like all of that stuff. Okay. But yeah, what's happening here? We increment, so we have the generic function, increment all. This is the function which is using the higher kind of type f, right? Which in this case, we are trying to increment all values inside of an option. And in this case, we're trying to increment all of the values instead of a list. I guess we can crunch the original list here too, right? So we have the option and we increment every value inside of it. We have a list, we increment every value inside of it, and we get the new list. There we go. And we have like the generic algorithm which works with any type. Back to the monads then? Maybe? So what's a monad? A monad, we have a type function. Monad m. Is it going to be inferred? No, it's not inferred here. I feel like this type annotation over here is not needed. I thought you need flat map for monad. Isn't monad like just the pure value, like the return and bind? I mean, flat map. I mean, flat map is the implementation, basically. I mean, flat map is bind, right? It's just like, or maybe like, I mean, these are the same things, right? Flat map versus bind. And they are just the same thing, right? Pure monadic functional reactive programming. Bind is not a word from category theory. I don't know why Haskell calls it that, but it sounds programming to me. Bind the payload to this variable to the input of the procedure. In category theory, you probably call it Kleisy evaluation if you call it anything. In category theory, monads are defined by their return and join operators. So in category theory, it's called join, not flat map either. Which are called unit and multiplication. Flat map, or better join map, is a good name for bind, since it really is obtained by first mapping over the functor and then using the monadic join. Oh wait, so wait, hold on. Join is, wait, what? Mapping and then joining, is it like a little bit different then, right? It says that it's using the monadic join, but is join the bind? Or is flat map the bind? Because flat map is map and join, right? Is this the bind? Is this flat map? join fmap. Yeah, maybe like I don't know. I think this is the definition from Haskell though. Haskell monad, control monad. Like, right? We have the method which is fmap, right? We have the no, this is functor. Oh, where's my monad? Applicative monad, right? So the functions are minimal complete definition. Yeah, just this plus the applicative itself. So this is it, right? We have the monad, we have this and this, that, right? I mean, it's not calling it bind, I guess, here, because it's calling it some symbols. It says sequentially composed to action, passing an available by the first into the argument of the second. SBS can be understood as do expression. And no, an alternative name for this function is bind, but some people may refer to it as flat map. Yeah, there we go. Okay, it's the same thing. So join is the flatten, which is MMB into MB. That's what the join is. That's not the bind. Yeah, that makes sense. Join is like when you have a list of lists, you get a single list. Yeah. Yeah. For monad, it's important to do MMB into MB, but isn't like join, like this? Oh, this flattening is already possible to do using flat map. Join is implementable using flat map, is it not? Or is it the other way around? No, I'm pretty sure. Like let's see if we have maybe let's not call it bind then. Let's call it flat map then. But it's weird because I don't want to call it a monad either. But sure, let's call it flat map. Fail to rename. Interesting. Flat map. Flat map. And what is this called then? This is not join, right? Sequentially initially composed to actions, discarding any value as in imperative languages. Does this have a name? When you just have you're discarding the first one and you're just using the second one. Just compose. Yeah. Sure. Let's call this compose. But we still use this syntax as in Haskell maybe. We have compose. Let's create join. I'm pretty sure join is possible, right? If we have a monad, type, then we have join. Join, we have a monad A, right? So we have T, we have monad, which is MMT, and this should return just empty, right? I'm pretty sure this is implementable. Yeah, like don't you just say as monad dot flat map? Don't you just flat map using the ID function? That's it, right? A x into x. That's all that you do, because like, yeah. Eager to see applicatives, traversals, and sequences. Yeah, let's see. Let's just try all of the things that are important to test. It seems like I'm panicking here though. Sum 3. OS monad. Oh, this is not inferred. Yeah. I was testing something here. Let's also like fix this. How do I detect? How do I detect that I am in the terminal? Print OSC 8. Can I like say here that this should just print the value if we are not in the terminal? FMT, we have a formatter. Does a formatter like Unix is a TTY? This is a file descriptor, but the FMT is not necessarily that, right? Can I know that if that a formatter camel is formatter TTY? Is formatter TTY in OCaml? I need to know. This formatter is often created from an out channel. To check if it's a TTY, you should check the underlying out channel. Yo, Brookzorker, hello, hello. Thank you for the raid. How are you doing? Did you finish your shell? Or not yet? I'm continuing to implement my own language, and we are testing the fact that my language can do monads right now. So we have like higher kind of types and stuff. It's I'm not sure why I got into this. Oh, camel, my camel. Yeah. Not finished the big rewrite handle piping built-ins to external commands. There's a huge refactoring that I will have to do too, which is called rewriting the language in itself. Hopefully we start that on that soon. Formatter is TTY. Match format formatter out channel. Exception out channel. Yeah, this is this a good one? Does that work? Hold on, can I say formatter format? I'm just going to do this here, you know. Wait, I want to have the tech functions or whatever. Like I'm doing the colors, I'm doing the other escapes, right? Unsee escapes. But maybe I'm doing this like only if. Oh wait, Unix is the TTY. Wait, hold on. I'm literally just doing this. Unix is a TTY. Yeah, yeah. Don't I just do the same? Let's do is a TTY. It's just like it's trying to catch an exception, but why would this? formatter descriptor about channel is what we want. I mean, that's what we do, right? FMT. That's what we do. Why did ChatGPT tell me that? Oh, yeah, formatter has the out channel. That makes sense. Format has the out channel, and channel has the descriptor. Yes, because this is std formatter is doing std out. That's why we're doing it like that. Is a TTY on Windows is really weird, by the way. Amon is just a monoid in the category of the anti-factors, correct? Yes, exactly. You are right. You know so much. What's an anti-functor, though? Where is my autocompletion? This stupid language. This does not exist. Formatter out channel is something that doesn't exist. This extracts the out channel. This doesn't exist. We should have a channel though somewhere, right? ChatGPT hallucinated? Yeah. Maybe. You can set formatter out channel. How do you get it though? Redirecting. Formatter out functions. Formatter. Abstract data comes from the pretty printer. Formatter about channel. So the formatter is abstract. We cannot see the insides of it. I think you cannot get it. Maybe I cannot. So what do I do then? How do I figure it out? Can I like have some option on the formatter then? Whether I wanted to like print certain things or not? Maybe this should be done through like semantic tokens then. Weird idea. Can you write a format? No, I think like so the way my I have syntax highlighting or like this, you know, cast highlight examples hello, right? This is done already, right? But if I like output this to like cat baby basically, right? You don't see the syntax highlighting anymore, and you don't see the escape codes either, right? So this works because I'm printing to the std out, but I'm printing basically using the formatter as tag functions, because tag functions are these, right? Mark open, marks tag, This is this. So I have string tag. Yeah. So we don't do anything in case it's not as, but I need to use the semantic token, semantic tags, or whatever this is called, you know, camel format. Somehow you unfollowed. I don't know. Maybe I don't know. What did I do? Why did you unfollow me? So yeah, we have string tag codes split on semicolon, ANSI escape. We have ANSI escapes, right? There we go. 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 ANSI escapes. We have a string tag, but in this case, the string tag is going to be well. I need to also like how do I want to use it, basically, right? Because this is the OSC8, and I want to basically, instead of inlining these escape codes here, I want to use a semantic tag. So do I put the data inside of a semantic tag? Let's see how this works in the print. If I can find the documentation for it. It's not that easy. S tags. String tag is a string tag S. String tags can be inserted either explicitly by using the constructor string tag or by using the dedicated format syntax this. So you just have the string inside of the things. So can I put anything there? This should be like probably simple strings. I want to like basically enclose my like. No, I don't know if how do I do this? There should be like nested tags or something. Oh, Camel, not Haskell. I'm tired. Well, I mean, we are looking at Haskell sometimes too. Yeah. I don't know. I wouldn't say that I know them very well. I can't wait until I don't have to use this language anymore. So I'm not trying to learn it more. I'm not sure what to learn is there, though. The language is simple, and that's the problem. I guess the libraries is the standard libraries what I don't learn. Do you plan to bootstrap sometime soon? Yeah, I think like I think really soon. So I solved Advent of Code with it. My bot is working using the code. Like my bot is written fully in this. It's a very simple one, but still. Now we're trying some monads, although monads are not really needed. Technically, monads are not the blockers for the rewrite. I don't need them. It's just I wanted to try to see if I can do that. HTTP server, sure. The compiler, I only have the interpreter, which is really slow right now. Did you do a list of features? No, not really. I mean, the biggest feature that is missing is the speed. Because if I self-host the language and I write a big program, then it's going to be really slow right now. So I need to have the compiler. Also, the LSP maybe needs to be faster. I don't know. Right now, it's completely not incremental. Doing some simple incrementality where we at least split something into the units, compilation units. Should be done. And then we don't recompile the thing if it didn't change. But that should be relatively easy. I just not focused on that because it's good enough for now for the simple programs. The weird way to bootstrap is just have a WASM backend, compile the compiler to WASM once, and then ship a very minimal WASM runtime. I'm planning to do JavaScript because WASM is more difficult than JavaScript because it's more low level, more lowering needs to happen, and that's more difficult. JavaScript as a compilation target sounds really nice. So my one of the Advent of codes, like Den 10 or something, it took like 20 minutes to run in my interpreter, and when I transpiled it to JavaScript using ChatGPT, but still the idea is the same, I guess, right? If we transpile it just like the ChatGPT did for me, then it just ran in less than a second. So my thing literally is 1,000 times slower than it needs to be, if not more. WASM runtime is smaller though. I don't care about the size of the runtime though right now. For self-hosting it doesn't matter. It just needs to be fast enough, right? Eventually I plan to do the full proper native compilation target. It's just not the priority. So like I need to know what I'm printing into here. This is very annoying. You want to do Advent of code in Excel sometime, just for the lols. Yeah. I'm not going to do that, so feel free to suffer. There is no formatter out channel function. You liar. You know, Camel, a formatter is an abstract type. There is no way to directly ask this TDI from the format itself because it could be right into a file stream buffer or a channel. The only way to check is to know that it was created from. Yes, but we don't have this information. What was it created from? You cannot ask the formatter itself, you have to ask the underlying channel. So we need to wrap the formatter inside of something else so that we know that the formatter is actually the thing, right? Okay, sure. Sure. Let's see here. Let's see here. We're going to say that type formatter is tty boolean, and formatter is stdlib formatter. I think I don't even include this here, right? Can I say that module std is stdlib format? So this is the standard formatter, and this is my formatter. So this is going to be like std. This is going to be fmt dot. Oh wait, but I cannot do that stupid thing. Wait, I cannot do that because this, like, I cannot literally. The formatting library doesn't expose this to me. Formatting library doesn't expose it to me because, like, when I'm having the format string, I can only pass to it like the function that accepts the formatter, not like the custom formatter type that I'm creating here, right? which means that I would need to thread it. How about, okay, I have another idea. I have another idea. I have another idea. Can you do custom formatter that drops the inner formatter? That's what I was trying to do, but I cannot do that because the like the formatting functionality is like hard coded into the OCaml language. It's like very magic, and I cannot customize it very well. What I can do though is I can like maybe use the effect system or something. But that's what the tags are for. It's just like I cannot do this for my current thing, maybe. Print open stack, print close stack, tag functions. pp set formatter stack functions. mark print state pp mark open tag mod. What is mod? Reading the code in standard library of OCaml is also something that is very interesting adventure, trying to decipher the variables which with like a single letter names. Can I do a task custom? Well, I mean, I'm usually just printing to the std out anyway. It's just like I don't have this information. How do I thread this information to the actual like printing functions? Because printing functions, they are all generic and they should work with any formatter. From the standard library, not the wrapped formatter. You can have side effects. No, I can have side effects. I can. But the problem is that what is the side effect that we need to do? The side effect is determining is if I'm at the standard library, right? Marks tag functions. Oh wait, hold on. No, that makes no sense. Like the formatter doesn't contain the state, right? From the semantic tags. I want to see the examples of using the semantic tags. We have semantic tags. Semantic tags are user-defined annotations to annotate user-specific operations on printed entities. Common usage of semantic tags is to text decoration to get specific font or text size rendering for display device, or marking delimitations of entities, HTML or text elements. So we tag RGB, right? Yeah. But how can I like what I want is to print a link basically in the terminal, right? And it should just look like a normal text and not a link if I'm not printing to the TTY, right? That's the thing that I'm trying to do. Let's ask ChatGPT. Can I use semantic tags to do what I want? I need to print text as link if as link or not as link. Print link. So right, we just open tag this and then we close the tag, right? And then we print the string. And then the formatter, if it's a link, if it's a TTY, then we do these things. This is my tag handlers. Yeah, but you like, but I need to print link text only if it's not TTY, not the URL, not the href, basically, right? I want to print the link text only when it's not the TTY. You can just make your tag handler decide whether to output anything based on the TTY detection. How do I do this? Load external library. No. Hold on. I'm almost there. I think ChatGPT is telling me something here. Don't print anything on TTY. No extra formatting. Set up formatter with tag functions. Set formatter tag functions. Default tag functions with open tag. Is this. Close tag is that. Function to print a link. We open FMT, a link tag. Oh, I mean, this is my, okay, so like, okay, I mean, yeah, whatever. Okay, whatever, fine. This is stupid. I see. Like, I just don't need to use like the angular brackets, but I actually open the tags manually, right? This is so annoying. Let's see here. So I'm going to, over here, print span. I don't print the span here, right? Wait, but I print the span to the string, basically, right? That's what I need to do. Let printed span is print span. So like make string. Print span like that. So this is my printed span. Then over here I will like pp format pp open semantic tag. What is a s tag? Dot. Beautiful. Oh wait. Oh, it's an extendable type. Interesting. Oh, and then there's a string tags. Okay, but I mean, yeah, but then semantic tag is whatever. We're just going to say like format dot. I'm going to have a OSC8, and this is going to be printed span. Yeah, how about that? And then we do format pp close s tag fmt. All right, I think I'm onto something here. And then we just print the value fmt like this. Yep. Format. Now we just say that type s tag plus equal OSC8 of string. Like right now, I'm just doing string. This could have something else for better efficiency, so I don't like make the string there, I guess, but it doesn't really matter. And so now when I am handling my thing, right, this is a string tag, but we can also say that this is an OSC8 of URL, basically, right? Or whatever. And in this case, since this is a TTY, right? Since this is a TTY, we're just going to say that tag functions, formatter stack functions, stack string. It must always be a string. A mark open. Mark close. And why does this return a string and is not like a function that is like print anything to the formatter? Why is this so annoying? I mean, sure, we can just say that I return in this case this joined with URL joined because
CAML made it annoying.
Yeah, I know, but why are they trying to make the life of the developers annoying? So we put the URL after this escape code and this escape code. Then we're expected to see the thing. So like, and then we close like that, right? Mark opens tag. Mark tag. Tag, tag, tag. Stag. Tag. How do I define how to like close it here? Mark tag, which? Do I use the which here? And escape tag which? Oh, I see. Which do I use the first or the second? So I guess we just use which on a tuple of two things, right? This is the opening and this is the closing sequence, and this should be a comma then. Okay. All right. Is that nice? Is that going to work? Let's try that. Right. Cast examples is monad. I need to like make sure that something is printed. Functor. Ag. Type into the two. Okay, let's just. Can I print? Let's try this. Let f be underscore comp time dbg print f. That's what I want. No, that doesn't work. Resource deadlock avoided. What? I have a resource deadlock now. What? I never had that before. What do you mean resource deadlock avoided? Mutex lock. Compiler compile. Log error. Because logging is doing the locking. And I'm looking. Wait, what? What? I get it. So opening the semantic tags creates a deadlock somehow. Why? Format. OSC. This is just thing that returns like the thing based on the string. Oh wait, I probably know why. Because make string is using fprintln lock, which is the same lock. Okay, that makes sense. That makes sense. Make string uses the same lock. But maybe like I should use a different lock here. You know? let lock be mutex create in this function. And this thing is less general. Okay, beautiful. Make string. Make string. Make string lock is mutex create. Let's just do that then. I'm just going to use make string lock, which is separate from actually outputting the other things. Okay, there we go. So this is F, and I can click it, right? I can go to this thing now. Okay, nice. But if I do this and then I cat, then we just don't see it. Okay, nice. I actually did it. Nice. Good. Good, good, good. Good, good, good. Surely commit. There's a lot of changes that I did. Why is my language server not working here? F/n. Is this Python Django? Not exactly. It's a little bit of a different thing. It's because I'm doing comp time printing. Comp time printing causes the thing to stop working. The LSP, because I'm printing to the same channel, which is the thing. Yeah, that makes sense. Okay. All right, nice. Bug. I'm going to remove the bug, by the way. I don't need that. Monad. Okay, back to monads. No, not back to monads. Did I not finish writing something here? Examples, HKT, functor, functor works, and monad. And monad panics. Okay, why? While we're evaluating this, I see. So yeah, I'm evaluating this, and this cannot be awaited. But this is during runtime, right? Because this is supposed to be compiled properly. Yeah. Okay. Why don't I see the language server? Maybe I need to reload the window. Yeah, I actually need to reload the window for some reason. Oh, but inlay hint failed. Why inlay hint failed? Raised by the primitive operation, deadlock avoided. Okay. Still, we still have the deadlock avoided thing. In the LSP now. So I'm having the lock, which is different from this lock, make string lock. But this is only done here. Okay, fprintf. What if I don't lock when making strings? Because strings don't need to be locking, right? Probably. Okay, now it works, and we have like the things. Okay, okay. Continuing. Continuing the monad. Where did we stop? We have join, empty, m type, empty, 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 mmt, empty. M as monad. Join. Let's try joining. I am implementing options and lists as monad. Oh wait, no. I did not. I did that only in the functors. So list as monad is right. So if I want to return, then txt into list. I don't have the list singleton, right? Maybe we can do a trip. Yeah, how about trip? Trip. And then we do trip singleton. Trip singleton. And then I can just do that, I guess, right? And we say that flat map. A-beam. A. F into how do I do that? Use std collection strip. Flat map. It's not just map, it's flat map. So I need to like we have function which takes like this and returns a trip. I mean, it is a flat map basically, right? So yeah, I guess what we do is something like this. We say that let mut result is trip create, I guess, the empty one, and we return result here. So this is a trip type. Okay, I see that some of the inference here is not present. Oh, by the way, over here also x is also not inferred. It's supposed to be inferred, right? Because option is not just some or none. Okay, some of the things are not here in the inference. They should be inferred because I'm implementing this thing. But the implementation anyway is just this, and then we like do trip iterate, right? We iterate over my current trip, and we have like the data x, and then we have it's more like into iterate there, right? But we do this, and we call function f with x, and that's like a new trip, and now I need to like join these things together, right? So I say result is trip join result and fx. Yeah, by the way, if I hover this, then it shows me the correct type, but if I hover the function itself, then it shows me like that some of the stuff is not inferred. Which is weird. Okay, so we will need to look into that. But that's it, right? So we have option and trip as a monad. So let's try to print trip to string a x to string let's try to create a, which is going to be join trip singleton 1 join trip singleton of trip singleton 1 trip join trip singleton 2 trip join trip singleton 3. Sometimes I wonder if he's just making all this stuff up as an elaborate prank on me. What do you mean? So T here, this is supposed to be like trip of integers, right? That's supposed to be here. Maybe that's why. Trips are not real. I don't believe you. What do you mean? There is a Wikipedia page about it. Means that's real. Yeah, okay, monads are real too. Trip T in 32 is not equal to trip T type underscore. So there's still this weird types. What's the problem here? Trip join singleton 1, singleton 2. Oh, yes, because this should be like Trip singleton, trip singleton. I'm actually not constructing this properly. Yeah, the trip of trips. What about now, though? What about now? I'll have a tuple. This comma is unnecessary. There we go. Ah. The first result was a Reddit thread where someone was like, monads are hard to define, but here's a book that explains it well. Like, what? Yeah. Okay, so now can I join the trip? Join. Because type shape underscore is not equal to this. I like, so this, it doesn't know that this is that. Can I say like underscore explicitly here? And now, but this doesn't know what this thing returns, right? This should return a trip of integers. So this was not inferred properly, right? So the monad here is trip. If I do that, then it should infer it. Yes, it does. What about running it? And then we are going to also print it. Okay, so it is 1, 2, 3, right? There we go. That's correct. That's correct. This comp time, let's remove this. What even is that? Let's ignore this. What was I trying to do here? I don't know. Let's remove this. Remove this, remove that. And there is some monadic stuff with the operators now. Okay, 1, 2, 3, sum 3. Okay, this is working. So, yeah. There is obviously some inference issue here, though, right? Because the fact that this is a trip should be inferred. This over here is for the stuff which is like do notation, right? Can we say like wrap always? Let's do maybe like /n here actually. Nah, this looks ugly. We don't want this. If any would probably work. If any. Do I put this in? I don't know. I guess I just print this all. Nah, this also doesn't work. All right, anyway, I don't know about the syntax and the formatting here. But what we are doing here, we have an optional monad, right? I don't like how this looks. I mean, not that I need to like how this looks, right? Can we do something like do notation though? Maybe we do something like do notation. So what I want to write here, I want to say that result is do, right? And then we say over here something like X is option. I'll probably do double semicolons here to differentiate. And then we do X, and we just do sum 2, and we say like Y. Oh, and sum 2 is Y. Yes, we do this, and then we return sum X plus Y. That's probably like easier to read than this operator sequence. What you doing, bratan? Bratan, we are doing the monads. You know what a monad is, right? Everyone knows what a monad is. Let's define the syntax for the do notation. Syntax do is just do, and then we do /n/t. Is that how I do it? I don't remember. I do not remember how I format this properly. Do body. I mean, I don't even need this to be inside of a do technically, because I'm going to implement syntax, you know, do body as literally just body, I think. Do you have a standard library? Yeah. I do. Oh, it's //n. Or is that all only like here? Hello? Or is this not formatted? Oh, I mean, it's not parsed because I don't define the other syntaxes, so I cannot test the formatter yet. Oh my god. Okay, implement syntax this. Implement syntax that. Let's just do it in order. Compose. Syntax. Syntax. So have like and then or whatever. Is just a double semicolon /and implement syntax A and B is going to be basically I mean, this is basically the same as just composing the things, ignoring the first one. It's just going to be compose A and B, right? This over here is right associative. The semicolons. Do I need to do that? Double semicolon as a separate tokens because my Lexer thinks that they're separate tokens. Unexpected end of file. Expected end of file. Why did you expect end of file? This is impl syntax. No. Did I not close something else earlier? It's because the priority is different, maybe. No, it doesn't make sense. It does not make sense here. Why is this not being parsed? Hello? If I remove this, then it's being parsed. Okay. Okay, which one? And then? Because the syntax of the semicolon. I see, I understand though. I actually understand. Yeah, that's probably like a bug in my parser. But it's okay. We're just going to use the, because I'm using the semicolon, I must use the same priority, I think. So it's going to be priority 0. Just like the normal semicolon. Right. Okay, and then we have like bind and then, right? Or whatever, which is going to be, you know, like variable, left arrow, like expression, and then semicolon b, right? So we have like variable expression b, and this is not composed. This is now actually the flat map, right? Right. So we just do something like expression, and then we do that operator, and then we say variable into b, right? That's what we disfigure this into. $. Okay. It formats this every time, which is weird. I think I don't need a /n, I just need to do a double backslash, right? Okay, now what's the priority? Because I feel like, so like, I get, okay, sure. So I guess since the do notation is going to reset the priorities then, let's do bodies any. But then I actually expect the /n, and I actually have like the done keyword. Maybe. Do this, done. Unexpected closing bracket over here. Oh, yes, there must be a done here, right? Yeah. Maybe this should be not always, but like if any, so that I can actually write it in a single line. So it should be like this into that, this into that, body, do body done. Yeah, let's do that. This also should be, if any, I suppose, which is going to be like space or /n. So we can do just this, and this should be if any. This should also be space /n. And we can just do that. Okay, and there you go. Everything is formatted. So here's my do notation, right? Result. We say option is this. So we basically, right? This is actual do notation now for the monads. X is int32, Y is that, and then we return some, and this returns in this thing, right? Let's see if this works. And it still works, right? Okay, do. Nice, nice, nice. What else do we try? What else do we try? This is looking a lot better than this syntax, which is the same code, right? Sure. So there is just some inference issues, I feel like, which is like right now this syntax only works for options because this is not inferred to be an option for some reason. And I also see some issues over here when I'm implementing option T. This over here and this over here, yeah, this is a wrong type inferred. But we basically have monads, right? We just need to do some annotations currently. And over here, this is not type checked at all, it seems, is the problem. I am not type checking at this. So this is a monad, and this is the type of this field in the monad, which is an option. But I'm not checking that this. No, wait, hold on. I am checking. I am checking. Like if I'm hovering this entire thing, then this is the type, but these types are incorrect. Anyway, I think I can commit this monads kinda here. So we like have monads, I think. But we're going to fix this. Do I fix that today though? Let's see if I can figure out the issue really quickly. And if not, then I don't know. So like, I know that the type of, I know that this over here, the type of this is this generic type. Right. So we have an expression generic, and I need to see in the type inference for expression generic. Expression generic type is just this. We have definition type, which is a maybe compiled function. I'm gonna have the definition. Oh wait, so I'm never saying that the definition and the definition type are type checking against each other, right? Maybe. Wait, but definition. But this is maybe compiled function. This may be compiled function. Hold on. No. So maybe it's in the core syntax then. Expression generic, def type, right? We create the definition. We create the definition type. Commit monads. I already committed. So yeah, definition, finishing compiling definition. We compile the body in the state, which is a separate scope. Sure, inject pattern bindings. Yeah. Finish compiling. Type argument is this. Finish compiling definition type. What's the definition type now? We have a body, which is expression constant, which is the type, which is this type. Body data type. Wait, yes. So like, that's very weird because if I have this function, we know that this function has this type. right? Oh, wait. We know that it is this. Because I'm unifying that with the other type. I guess it's in the unification. Hold on. Unification, inference, implementation over here. Unite generic, type generic. Type generic, unite type generic. This is the thing, right? Yeah, we have type generic. And the type generic is basically, so like I'm storing the generic type in its normalized form, basically, right? I'm storing it in its normalized form. But when I evaluate it, I actually evaluate the original form. Wait, no. That's only for the generic types, not for generics themselves. For the generics themselves, I don't normalize anything. So I see, I think. Like I never touch the types on in the body of the generic function if I know the type of the generic, right? So let's do a simple example. Generics, right? This, by the way, seems like... Have I checked out the fresh editor yet? No. Was there a new editor dropped out recently? What's the new editor? What's it called? Let's have example test KS. Sine law. All right, let me just figure the example that doesn't work right now, right? So I want to say something like this. I want to have the generic G, right, which is like T X into X, right? What's the type of this? T underscore into underscore, right? We don't know what X is. We don't know that this is of type T, right? This is the ID function. This is the ID function. I can say that this function is properly typed if I annotate the type over there, obviously, right? But what if I instead say that this is the type T into T, right? Because that's the type here. Right? So that's the type. T in this case, this is a type. I cannot hover inside of the generic type expressions, by the way. But anyway, so T, now we don't know anything here. Like, we still don't know what this is. This is still inferred. We know that the type of this expression must be T, but if we look here, then it's not inferred. Okay, that's the problem. Is this a terminal one? a terminal text editor you can just use. Okay. What's it called? It's called Fresh. Let's see the nicks. There's no nicks? That's a crime. Install. There is nicks? Not here though, right? I mean, is it on the GitHub releases? I mean, it's not the releases, right? I can just... there is a flake here, I guess. Yeah, sure. Let's do this. Let's do this CD project custom cast. Let's say nix run. Nix run GitHub. Sign law fresh. I'm going to like build it from scratch though if I do this, right? Not use the cache. Or do you mean that it's in the next packages? Fresh. Fresh is a bad name for the editor though, I think. Too generic name, no? I don't think it's in the next packages. And this over here is going to build this thing from sources. Unstable. There's fresh fetch though. Fresh take on new fetch. Let's try this one. Next run. Fresh fetch. Do I like the fresh fetch more? I don't know. Same stuff. All right, cargo source, cargo package. How long do you think it will take for me to build this? All right, anyway, back to this problem. So I have asserted that the type of ID is this, but the types are not inferred, even although I'm annotating it over here. It's still downloaded. It's not even building, it's downloading the thing still. It's downloading Rust itself. So how should this work, right? Like when yeah. Yeah. Like the type inference should work based on the unified, based on the normalized representation of this body of this like expression, which is a generic. It says nix run GitHub. That's what I did, yeah. It's compiling now. Fresh editor dependencies. Tree seater is compiling. X11 is compiling. All right. Do I even have the RAM for this? I have 6 GB RAM free. I mean, 19 available. I guess a lot of this is in the cache. Maybe we're fine. I feel the lag though, as the Rust compiles on my machine. Does the stream lag yet? Okay, but yeah, so here's the idea, right? What we're doing is we are converting this generic into this into the normalized form. the type of it. Specifically, what are we doing? We are changing every single variable, which is the argument, into like the normalized arguments, which basically in this case is converting to like underscore 0, because this only has a single argument, right? But in order to perform the type checking and to do it backwards now, right? And to do it backwards, so I need to like denormalize the thing. I need to actually denormalize the thing. How do I do that? How do I do that? Evaluated with normalized bindings. Evaluated with original bindings. Evaluated with normalized bindings is this. So here's what we're doing. We are constructing the new normalized argument, and then I just call the function with the normalized argument, and that's it, right? But the thing is that this is the generic type of the maybe compiled function. Yeah. Generic type. This gives me the definition of the function with the expression of the function that is the generic type and converts it into this. Yes. The logic must be here somewhere. If I evaluate it with original bindings, if I know what this is, then I can denormalize it, and I can say, right, we have the definition, def type. Is this not used? Type function. Yeah, so like, yeah, there we go. We have the definition. This is a maybe compiled function. But we never set the types here, right? We never use the types of it. Yes. Wait, but what I want is to set the type of the definition, which is not the type. Oh, look at this. The editor is opened. The editor is opened. Do you think it's going to work with like... How do I quit it? How do I quit it? Colon Q doesn't work. F1. Okay, fresh. File management. F1 works. It's supposed to use like VS Code, I guess, right? Hello world. Then I can select just like in VS Code or something. Highlights the world, yeah. Control X, Control V, so like just like VS Code. Kind of, maybe. The close buttons don't work. File Explorer. Okay. Does it work with oh, discard. Discard this file. Discard this file. Can I open the this? Read bottom. Yeah. How do I get the LSP working? Or is the LSP for OCaml not working in this thing? LSP. Show hover info. So this doesn't work. Restart server. No LSP configured for this file type. So they just don't have the configuration for OCaml, I guess, right? Fresh. I mean, it looks nice out of the box. Yeah, I think this... I don't know. Maybe this is too many features. I'm not sure if I like the menu line, but we can probably hide it, right? Keyboard shortcuts. Show fresh manual. Quick start, readme. Can I search for the readme? Search and replace. Incremental search with match highlighting. Replace, release all. Interactive query replace. Git grep across the entire repository. Keyboard shortcuts. How do I search? Control F. Search. How do I find the next thing? Next search F3. Control F, LSP. Like I want to find LSP in help. LSP. Language server. How to configure the language server? Documentation. README. How do I go here? How do I open README MD? This looks like a link. Can I go there? This is just a README. All right. I'm not sure if I need the terminal editor, but it's TypeScript extensibility. It's literally like VS Code, but with but in the terminal. But faster? Yeah, I guess it's just faster. Is there a key map which like makes it more Vim-like, maybe? Probably like a plugin for it, right? Not sure if I would what I would prefer. Wait, does it have multi-cursor though? That's the important question. It does. Command 1 2 3. Command 1 2 3. It does. That's already better than Vim. Okay. What I don't like is that it's not changing the cursor, like the cursor to like the vertical bar. That should be possible, right? Or is that the problem with my terminal? If I go to NeoVim, yeah, like NeoVim does that, right? Like, it makes me think that I'm in normal mode and not in the insert mode. Right, anyway, I need to like fix my bugs. Fix generic inference of generics based on type of generic. All right, let's see. How should this work? So this is the type, and this is the value. Right? And this is not inferred to be of type T, even though this is specified here. Okay, that's because so let's first see when I have expression function. Function expression has the type here already inferred, right? And definition has also this thing already inferred. Core syntax, definition type is this constant. Okay, definition type is a constant, which is body type. Yes. Okay. And the argument is the same argument. Okay, so here, okay, so what I need to do is I need to basically just evaluate this normally, which I'm already doing, but I need to unify the, yeah. I think what I need to do is I need to unify, I need to unify the normalized form and the non-normalized form by denormalizing the normalized form. We have evaluated with normalized bindings, evaluated with original bindings. They must be the same, but we are not asserting that. But we cannot just say that they are the same. They are the same with like substitution of the variables, right? So I actually have this construct bindings args. I already have it here. I have the argument compiled arg. I guess I'm just going to do this from scratch or whatever. To have evaluated with normalized bindings and with the original bindings, right? The one with original bindings is what we are actually like doing, but I need to substitute it back, or I can also evaluate this and then substitute back with original bindings, and then I substitute it with original bindings, this one, right? I can subtract the bindings argument. Yeah, I think I like this idea here. I think I like this idea here. What is fork? My compiler is async. So it's creating a new async task to do. Because I need to not block the compilation if I cannot infer what this is right now, basically. So it's a fork. Like, I mean, I guess it should be called spawn, not a fork, right? Yeah, it's just a spawn. So we have this thing, evaluate, result, to do expected type, result. Yeah, I just say that result. Fork sounds like C combinator. I mean, there is forking like man fork, right? Basic process management. Fork creates a new process. Right? But I mean, you create a new process. Like, why is this function not called spawn? Because it's just spawning a new process, right? Hello from the child, hello from the parent. There's a child-parent relationship, which I don't really care about, I guess, is another distinction. But, yeah. And I guess forking is actually like creating two processes with like the same code, which is a little different. It's not really a Linux thing though, right? I think fork, is there like no fork on Windows? Fork Windows? What is the closest thing Windows has to fork? Cygwin has fully featured fork on Windows. Otherwise, you can take a look at Cygwin implements fork. It does not map well on top of the Win32 API. This makes it very difficult to implement correctly. Currently, Cygwin fork is a non-copy on write implementation similar to what was present in early flavors of Unix.
Hello, it's lovely.
Hello, it's lovely. No, it's not cmd/c because it also keeps the memory like it has like the clone on write memory, I think, right? Like it's technically like cloning your memory. So the child process and the current process have the same thing. Yeah, okay, it's not what I'm doing. Yeah, I should not call it fork. Because fork basically duplicates your current process. It becomes two processes, which can like use your program state, which you have already evaluated, but differently. That's not what I'm doing. Yeah. Fine, I'll rename it to spawn fork spawn. Oh wait, I think this is why. I think this is why, maybe. Because I'm using the effect library, and this is also called fork. Why are they calling it fork? Because I'm using a library that's also calling it fork. That's probably the reason. OCaml EIO. So it's like promise or task run. Yeah, exactly. It's literally just that. An async computation. Beautiful documentation. Oh, wait, maybe I need to go here. Yeah, we have promises and things. Where's the documentation? This is the one? Fork. So fork runs this function in new fiber, but does not wait for it to complete. So why is it not called a spawn? I don't know. It's not a separate thread. This is like green threads. Fibers is what the word is used here, right? So it has nothing to do with multi-threading. It's about concurrency. It can work on the same thread, but concurrently. Something like event loop. I mean, just like task run and promise in JavaScript also. JavaScript is single-threaded, and you can still do async stuff there. So yeah, there's something similar to the event loop. I don't know why am I looking this up, but now you made me interested. Why? OCaml EIO as a function called fork. Shouldn't it be called spawn instead? For JavaScript, it depends on the runtime. Sometimes Node can use separate thread. Yeah, but semantically, it's like it doesn't matter, right? Because you can move your thing to another thread, I guess. Like you are still not going to like you can move to a different thread, but you are not going to like run multiple promises. Like, what's the word? In parallel, right? That's not going to happen in Node still, I think, right? Unless you use some specific APIs, which are no longer the same things. Kane ONG, hello. EIO calls it fork because it's borrowing the mental model of Unix, not the literal behavior. In Unix, fork means split execution here and let both parts run. Well, I mean, I guess, yes, like maybe calling it fork is not such a bad of an idea then, right? Like because that's what we mean. We split the execution here and both the parts run, right? Although technically, like, I don't know. Spawn usually implies a new thing I've created, it lives somewhere else. You might track it, join it, or forget it. I mean, yeah. That's what I'm doing. How is that not EIO's vibe? EIO's fork doesn't detach, doesn't outlive its scope. That's not true. Well, I mean, it doesn't outlive the scope, right? Because the scope, like, gets, like, captured or something. No, it does outlive its scope. It just, like, captures some variables from the scope. Monads versus monoids. Any info on semigroups? Semigroups? We only have written the monad. We did not write the monoid. We can try doing that though. And semigroup. Sure. To see if it works. Like groups. Okay. Semigroup has not identity, that's it. That's the only difference. But a monoid has an identity, right? So a semigroup is not a monoid, right? But a monoid is a semigroup. Is that correct? Monoid, cube, or whatever. Where's the cube of the groups? Magma group, there we go. Identity, monoid, semigroup, associativity, magma. Yeah. Right. I don't know what to write, I guess, in terms of code then. Forget about it. Forget about it. Monoid and monad both has identity. Yeah. Wasn't there like the full tesseract here though, or something? Anyway, I'm trying to do something. I'm looking for a bug in my generics. Over here we have the ID function. This is the type of the ID function. This is the definition of the ID function. And this is not inferred based on the type that I'm giving it. That's the bug. Right? So once again, I am doing the type inference for generics because I'm storing the generic types in the normalized form, and I never unify that with the original form. So the idea here is that we like evaluate using the original form. And then I substitute that Wait, but how can I substitute if that is not known? I need to like substitute backwards actually. Can you imagine people of 19th century lived without TVs and internet and play these mind games with abstract mental math? Yeah. Well, I mean, what else was there to do? I need to like substitute backwards, I think, because this over here is not inferred. I need to do it in both directions actually, right? I need to say that evaluated with normalized bindings, substituted like backwards is equal to the original binding, and then this one substituted backwards is equal to that one. This is why I had so many children as well, right? So here's what I'm saying, that evaluated with original bindings, I substitute the bindings. The question is, in what scope am I going to do that? Not in the current scope, in the scope where like we have a specific scope. Construct bindings argument. Okay, let's do fork function. I'm going to wait for the function to be compiled. I'm going to wait for the function to be compiled, and the original bindings I substitute by doing that. Yeah. State. Let's call this substitution state. So say evaluated with normalized bindings, inference type, expect inferred as this thing. So what is the substate here? That's the question, right? Substate is state with scope being something. This is interpreter scope, right? Yes. So this is scope initialize with values recursive false, parent none, and then the locals. So this is like the substitutions, and substitution is just like I need to pattern match the thing. We construct normalized bindings args, and then I say that compiled argument pattern match span place is going to be place init not inherit, value is the argument, and I pattern match against the pattern. Yep, this is going to be like matched and matches, and this is my substitutions actually, right? My locals, scope locals, matched, if not matched. Like I have this already somewhere, right? Fail to pattern match. Fail to pattern match. Actually, no. Said before that span is named argument. But what it actually contains is some kind of context. A span is this span is like it's like the location in the source code, which is a range, right? So it's like basically two positions in the source code, and the things between them is the span. That's what's called the span. So right, so it contains the start, the finish, and the position, and the file in which we are currently. Matched. If not matched, then error Question mark. That's supposed to not happen. I'm not sure, maybe we can even panic there. Okay, let's try this. I think this is still not going to work though, right? Yes, this is still not going to work because so what we are doing right now, I like, so we know that the type of X here is underscore, right? This is some not inferred type. What I'm doing here is I'm saying that if I substitute this, if this contains T, I substitute T with underscore 0, then it must be equal to like this thing over here, right? But how do I substitute if I don't know what it is yet? That's the question, right? So it doesn't actually do any work because of that. But we need to do it in the other direction too. We need to do both directions basically, right? So let's do this separately. We are wait compiled, but now how do I do that? I need to like flip my locals. Is that even possible? So it's like say that evaluated with original bindings is evaluated with normalized bindings substituted with the substitutions. But the substitutions in this case is this substitutions inversed. It's from the Laxer. Well, I mean, it's from the Laxer and the parser, right? Because the spans, like, we have expressions. It's not just a single token, right? The full expression is having a span, right? But yeah, and every single token also has the span. Laxer and parser. I mean, parser just combines like the existing spans of the tokens, I guess, to construct the spans of the ASTs. So just like invert this thing here. How do I do that? What is scope locals, right? This thing we have by symbol map empty. Like I cannot just construct the original bindings and pattern match. And pattern match there. Right? Maybe I need to have like a separate thing. Maybe let's do construct not the normalized bindings org. Scope locals, this is having by symbol, right? So the symbol map and symbol into like a place basically, right? Where we have a value which is going to be like the binding. Normalized bindings. If I have this value of this subs, can I do the other way? I mean, I can do two pattern matches though, right? Like I can construct both normalized And I construct original bindings, which is just construct bindings arg, right? Original binding arg is this, and normalized arg original arg. Let's do that. So this is going to be original subs. Is we pattern match the original arg, and then we also pattern match the normalized arg with normalized sub. So my subs is, so this is going to be scope locals, which is by symbol. It's going to be symbol map dot, like basically I need to like not union but like merge maybe. Yeah, because like it says A option, B option, and C option connect, so I can like change the type here too. So I'm merging the original subs, and wait, but the symbols are different too, right? Because I need to like swap the symbol. The symbol should be the one from that one. Okay. Fine. Can I like I need to like merge the maps and then just walk it basically, right? By symbol. Is this mutable? It's not mutable. Subs. Sub is subs. Let's do that. Let subs be symbol map empty ref. Okay, so we're just going to say symbol map union. No, not union. I literally need to merge it, right? I need to merge. If I have function A, B, I should like literally have both of them. So like A and B. Like that, and like sum A and B. Merge. And to merge original args and normalized subs by symbol, original subs by symbol. This over here are two options. So I'm to say that let A, do you have a let star? That works, right? Let A is A, let B is B. And then return sum AB, right? Okay, and then we do symbol map iterate, right? Let star. This is the monadic thing. That is the monadic thing. Yes. So we are doing the monad, which is an option, right? So in Haskell, I don't know what you do it in F#, but in Haskell you just do like basically it's do notation, A is A, B is B, and then I return A and B, I guess, right? That's what I do here. I don't like how it looks, but doing like explicit pattern matching is also annoying. You had something in F# to do that, right? Okay, you have immutable values everywhere, or you can mutate structure in your language. Yeah. I do have mutation, but like right now I don't have like checked mutation. So like my language is impure right now. The idea for the future is to actually have the effect system, and mutation is going to be handled through the effect system too. So like it's still, if you want a function to be pure, it can be pure. You can use mutation inside and like encapsulate it, similarly to how in a Haskell you would like use an ST monad if you wanted to do like actual mutation or something, or I mean any monad, like state monad, right, to do mutation. But we do it more like the traditional languages without the actual monads. We instead say that the functions can have effects, but the effect system is tracking them. Right? So instead of saying that your main function is a function that returns the IO monad, which is the object, which it can be like evaluated to actually run your program. So your main function is not the program. Your main function is in Haskell is the meta program, which constructs the program that you actually run later, which is the IO monad. Instead of doing something like that, we just say that main function is the normal function, but it has access to IO basically, which means that it can perform the effects which are interacting with the outside world. It's a similar concept, but it's different, because we don't treat code as data basically, because when you write code you don't really like think about it like data. I think it should still be possible though, but normally when you're writing stuff you're like not thinking about code as data basically, right? You are thinking about the effects that you are performing. So it's more it's easier to like understand, I guess, maybe. Or maybe it's just me because I'm not a function programmer at heart. But yeah, there's a bunch of programming languages that are appearing with the effect systems right now. More controllable. It's not more controllable even, right? Like the monads are literally the solution to the same problem. It's kind of the same solution. I mean, it's not the same solution, but it's, you know, it's another solution to the same problem, to control the side effects. It is more composable, maybe, is a word that could be used. Maybe it's like easier to write code like that. Yeah, but that's all in theory, because I have never actually write it. I mean, I did write a little bit of code in effectful languages, but even in Haskell, I use the effectful library, which implements effects, the effect system using the monads. But yeah, I did not have too much experience with it. So composable is a plus for effect system. What are the minuses? What are some disadvantages? I don't know, like when you have the effect system, I feel like your language, like, is there a way that a language has the effect system and doesn't have higher kind of types, so it cannot do monads though? Because like the language should be able to do both, I think. So effect systems are powerful, but they make your brain sweat in places monads already paved. Type complexity explodes. Effect rows, sub-effecting, handlers, masking, polymorphic effects. Maybe the implementation is more difficult of the language with the effect systems, because it's like a new thing. The monads, they existed for a long time. Monads are like, and effects is like the new thing. Higher order effects are nightmare, but about higher order, like the other things, I don't know. Reasoning becomes non-local. With monads, effects are explicit in the type constructor. With effect systems, the absence of an effect often matters more than presence. You end up reasoning about what isn't allowed rather than what's allowed, which is subtle and error prone. I'm not sure here. Performance transparency suffers. I think that's the problem of the monads too. At least monads at least make the performance sins look ugly enough to notice. Okay. Yeah, I don't know. I don't know, what is the downside? Do you write code in a pure functional way? I expect most people here don't. Rewinding the stack is difficult, like if you want effects with continuations, etc. Yeah, but like, how do you do that with monads? Monads means that you basically, like, when you are doing monads, you're basically putting your stack into a data structure. So, like, you know, like, you have your stack as a value, basically, right? Because you have, like, all your code is of the value. You can do, like, continuations using the monads, too. Right? But your continuation is a value which contains like the stack inside of it. So right, like what is a continuation, right? It's the code that you need to evaluate plus the state, which is like the stack, right? So like when you're doing the effect system, it's handled for you implicitly, I guess, and in the monads it's like explicit, maybe the difference. Like how is your stack represented in the memory when you are defining your monads? Unless it's some built-in monad, like IO monad or the ST monad, I guess. Inflicts effects are like traits, and you can provide effect implementations specific scope, so it's like environment. Yes. And like a monad is also like environment, right? Monad is the like well, I mean, monad is not the environment, right? You monad is like container. No, like monad is like a monad is the data structure that can be evaluated given the environment, right? So for example, you have the state monad, right? State monad. The state monad itself is basically the code that can use the state, right? But then when you say run state, this is basically you providing the handler, which is like the effect implementation for the specific scope. So this over here is basically saying that we create the effect handler, and this code inside, this do notation, this code can use the state effect, right? So yeah. So effect handlers is more like these functions that evaluate the monads, I guess. right? Walk state, do light cardio, get fit, 69, nice. I didn't know Jerem was fluent in monads. All right. But yeah, monad is basically a way to encapsulate effectable code as and store it as data, I guess, right? But you rarely need to think about your code like that. You just want to do something that performs the effect. And you don't need to store as data. Like, think about even like options and stuff, right? Like, one of the things that is very common is Rust, like, is like in a lot of these languages, like Rust, you use the functions that returns a result, right? Instead of like throwing exceptions, for example, right? But why is that good, actually? The only reason this is good is because this makes it like visible to the type system, because normal effects, normal like exceptions that most programming languages have, they are unchecked, they are invisible to the type system, and you never know if your function can throw or cannot throw an error. So that's why this is good. But is it actually useful? In a lot of cases, using results here when you are just when you just want to handle some errors, this, in my opinion, is sometimes very annoying, especially when you're like, I don't know, you're iterating over a container, you like doing some maps there, and then you want to now throw the error from the original function from inside of a lambda. Then you, instead of a map, you need to do like a try map and stuff like that. It all becomes very annoying. And in a language with the effect system, it also like you basically go back to the original idea that you like throw an exception, for example, right? But it is still present in the type system is the idea. So we still maintain the benefit of knowing if the function can fail or cannot fail without it being annoying to write. Right? So compare this, for example, like Rust does this. If you compare this to Zig error handling, Zig does something more similar to effects, I guess. Because you don't need to wrap your results in the OK wrapper, because if you're just returning OK, you just return the value. But if you return an error, then like there is this exclamation mark, which means that this function can throw an error. It's like kind of like more similar to this, but this is a specific solution just for error handling, and in the effect system is a more general thing, which is not about just the errors, it's about a lot of other things. It's a more general approach, basically. Just don't compare with Go. Yeah, Go is like on the bottom of the on the imaginary like tier list of programming languages for me. You might be a genius. I don't think so. I'm just doing things. All right, anyway, so we were doing this bug. We were doing this bug over here, right? And this is still not fixed. So let's fix it. If I can. So I need to like substitute this. We have that. I'm going to do this, yes. I'm ignoring the symbol, but I have the A and B. I merge. Okay, I merge original and I merge normalized. These are two locals, right? These are two locals. Value is original place. I just 3D place or whatever. Original read x is x, like this must be scope types interpreter local. I have x dot place read place span. Your smile says otherwise. Yeah, maybe I am a genius. Maybe. What's the definition of a genius, though? Like, if I actually can get this language to work, maybe then I am a genius. But it's not there yet, you know? If I have everything that I have planned here actually working somehow. Original read, and then we say that normalized is normalized read. We replace, that's like value. Then I need the value to be value expect binding, basically, right? Okay, sure, let's do await inferred, and we match this. Like, I know that this must be a value blocked, right? I know that this must be a value blocked. Which is blocked, shape is blocked value binding. Beam. So this returns the binding itself. That's what I'm after. Fail with should never panic. Shape, I don't care about the other things, right? So I have the binding. This is the binding and this is the binding, right? So we have two bindings. In F sharp, you can do it like this, computation expressions. Yeah. So it's let exclamation mark. And you can also, yeah, I remember I was reading about this. You can do like custom, like custom things there too. I think after the exclamation mark, you can do some like custom things. Like in OCaml, you're kind of limited, I think, to well, I mean, I don't like how this looks in F sharp there either. It's just a let exclamation mark instead of a let star. Can I do let star star? Yeah, I guess I can. Like, I can do any amount of stars here. Yeah. Okay, so I'm not really limited by the thing. I'm still limited by what is allowed here. I think it can be like any like operators maybe. Yeah. Any math operators. And you can construct meaning for those. But you can do like this. Async, let. Yeah. Which is, yeah, sure. I mean, yeah, that's the same thing. In F sharp though, this syntax depends on this thing, right? And in OCaml, this is basically a value which you need to bring in scope, which implements this thing. So if you want to like match like async and then option something, then I think it's probably a lot cleaner in F sharp than in OCaml. It's just async monad. Yeah, in this case it's the async monad. In this case I'm doing the option monad. Yeah, just like I said, it's the monadic, it's the do notation here. All right, so we have bindings, and now I need to add to the subs, right? So I need to say subs is subs into symbol map add. So I need to add the symbol of the what am I doing here, right? I'm doing normalized and change that into the original, right? So I add the normalized label, normalized name, which is a symbol, and that is going to be the original. But I mean, I don't read this thing then, right? That's what I do. Okay, is that going to work? Let's see. First try, please. It did not work. It did not work. Okay. How do I test this? How do I see what's happening? I want to print something. Like in this specific example, I'm not even using anything from the standard library. So I can remove this. And this is just the syntax. And all of this is core syntax, I think. So I can remove the standard library altogether. Wait, blocked value shape 0 is not equal to t. Okay, hold on. I did something wrong. I did something wrong. In this case, right? Original bindings is normalized bindings with substituted subs. Can I like print the subs here? That would be really nice, right? Yeah, let's do this. Subs by symbol map, iterate function, print. Let's do something like this function, symbol local. I like print this is equal to that, which is symbol print symbol and value print let me call this read local. This is useful. Print read local. Do you have something like debug? I don't think so. Like, I need to specify how to print things. I guess I could like implement the printing for the entire like struct like this. Then I would not need to iterate. Oh, read local is not the value, right? Yeah, that's the binding. Well, I mean, it means that I need to do binding print, right? Yeah. Read local. Let's see. Right, so I say 0 is equal to k and 1 is equal to v, which is correct, by the way, right? Which is correct. So I'm trying to substitute 0 into k and 1 into v. That's what I'm trying to do. Everything on the left side should be like underscore 0 t2 string. Why is this still called t2 string? Let's call this t. T single. TT. Oh, you like pass through the debug. I mean, we could have a function like that. Yeah. But I don't know why. Blocked value shape 0 is not equal to t. When I'm compiling this thing, the entire thing so I'm guessing it's about the trip t then, probably. Evaluated with original bindings is equal to normalized bindings, but then we substitute this, right? So you're saying that if I'm going to comment this and don't do anything here, then this is going to not have any problems? Yes. So why is that a problem? Let's log further. This looks correct. Let's just say that this is normalized subbed back to original. Normalized subbed back to original is this. So let's do print. Original is this. Norm back to original is this. Type print evaluated with original bindings, print, subbed back, normalized, subbed back to original. Is it hard to debug OCaml step by step in VS Code? It's like how do I put the breakpoint though is the question. I don't know. I'm not very good at debugging. I almost never debug at all. So maybe there is a way like you can put a breakpoint with like with a condition, right? When the expression value is to true. Yeah, maybe that's how you do it. I don't know. I never tried debugging. I want to like figure out how to do debugging for my language though, because having a debugger for cast would be nice. So I need to implement the debug adapter protocol or whatever, similar to LSP. Didn't look into that yet. Wait, so original is this. Norm back to original is that. And I don't see the problem. Blocked value shape, this is not equal to t here. Zero is not equal to t. Because I don't see any like zeros and anything, right? Or do I? Let's see, clear. Do I see any underscore zeros here? I don't. Should you convert index into symbol? That is a symbol already. That's why it has underscores. Right? It's a file fake normalized binding. That is a symbol. It has underscore on it. It's like what this means is that I'm doing like alpha normalization, I guess, right? That's what someone called that. Alpha equivalence lambda calculus, right? That's what we are talking about here. Lambda calculus. Alpha equivalence yeah, basically it means that if we change the variable names, then the thing is still equivalent, right? So if I change the variable name of t into underscore 0 and then back, it should be the same thing, right? That's the idea that I'm trying to do here. Oh, wait, because it says underscores everywhere. Oh, wait. Like, this should definitely be some names, right? Original mode underscore k v. Shape 0 is not t. Let me try to read this code again. Well, I mean, the substitution is definitely correct, right? And the idea is that when I substitute back, there should be no zeros, right? There should be no zeros. So why am I having this problem if 0 is substituted back into t? If it is substituted back into t, the original subs, the subs that I have is this, and I construct the state with this scope, which is a new scope, so I don't see the problem. Can I also print normalized? Original this, norm is this. Maybe I could like wait until all of these are inferred. Wait, this is not even printing anything? Wait, why is nothing printed right now? Oh, because I'm outputting, I'm redirecting my output. Never mind. Right, original TT into TT and stuff. KV. Like, the error is happening over here, right? So this looks like the type of the iterate over here. Maybe if I print this after it's evaluated. Because it's not evaluated when I'm printing it yet, is the problem? Is that the problem? You mean if you sub same variables on both types, they must be the same if the original names were different? Yeah. Yes, exactly. So what I'm doing here, this is a process which is called normalization by evaluation, as far as I understand. So we are trying to see if two functions behave the same, right? How do we figure that out? Well, we do that by converting the functions into normalized forms. And what does it mean to convert it to the normalized forms? We do that by normalization by evaluation. Which means that we evaluate everything that we can, unless we are stuck on a variable which is a runtime value and not available to us at compile time, basically. In which case we say that, like, okay, well, the value here is the thing that is only available at runtime. And its name is this, right? So then it means that we have to still have the names after evaluations available to us, right? Which is why, like, which is how we print this, like, t's and stuff. This is just a value which is not known yet, because this is an argument to the current generic function. But yeah, we basically convert the things to the normalized form by doing that, and we still have these variables. And in order to like normalize it even further, we are changing these variable names into the normalized variable names, which is based on the function arguments. Basically, we rename the first argument to _0 and the second argument to _1, and like that, right? Yeah, so there you go. So this is the function type in the original form. It is like t and t into underscore, right? But the normalized form of the function type is _0 into this, right? Which we can now actually compare two functions if they are equal, because now all of the names are going to be equal too, since we have done that. And normalized back to original is actually equal to tt into underscore. Okay, hold on. This seems like this is supposed to work. So the question is, why does it not work? Maybe all I need to do, let's try, you know, because like debugging the standard library here. Standard library is already not that small. Let's try to comment out the collections and like do that. And then like try to do the monads. I still have the issue in the standard library in some other generic. So like in this case for the randomness, right? Okay, can I comment the random module? Standard library, self. Like, I mean, nothing works now, right? I think what we can do is I can like comment everything out then. Yeah, I think let's comment everything out. I mean, yeah, let's actually comment everything out. I need to like have a way to work without standard library, because this over here is a little bit annoying, right? So if I run, prelude is not there now, right? But if I just try to run the test, because the test is not even using the standard library, there you go. So now we know that original is tt, normalized is 0 into 0, back in the original is tt, right? There we go. So like that is this thing. Can I remove the printing now? Seems like OCaml is also not that fast to compile anymore on my project here. Where's my LSP? Okay, so this did not help. This did not help. I think I know why though. So like, what should happen though? Wait, what should happen? What should happen? No, wait. No, it should work. Right? So the way it's supposed to work, right? We know that the normalized form of this type and this type is the same, right? The normalized form of this type is basically this underscore into this underscore, right? Oh, wait. The normalized form is where this underscore is substituted, though. This is, yeah, I don't know. You know what? We're just going to drop this for now. We have something that's working. Might need to like undo this. Let's actually like say if false here to do, then I'm going to run this code. You know. And I'm going to uncomment my standard library. Prelude. Delete this file. Trip was renamed back. Interpreter core. Read local. Well, I mean, this is nothing. Wait, I didn't do anything. Right? I just over here fix the generic stuff, right? Okay. The failed attempt at fixing generic inference. But if I like right now, if I reload the language server, it should still all work, right? I think everything should work right now. HKT monad, right? This thing still works. The problem is that we cannot infer some things. Some things are still not inferred, even though they should be. For some weird reason. Okay, I'm just going to figure that out. Maybe next time. Or off stream. There was another option that I was thinking about is like dropping. So like what I'm trying to do is too powerful inference. We can instead try a simpler inference algorithm, which will allow like require more annotations, but it's just a lot simpler. Something similar to what the non-functional languages are doing usually. But it's almost working, so I don't know. We got monotone dependent type today. Dependent types, so like we have higher kind of types, which is a very, very limited form of dependent types. I think I can extend what I'm doing to support more forms of dependent types. But I'm not even sure like what would I use it for yet. So I'm not even sure that I need the like higher kind of types in my regular code in order to rewrite the language in itself. I don't think I need higher kind of types. It's just nice to be able to do that. I don't know, for some weird reason, makes me like a proper nerd or whatever. But I feel like the inference algorithm is maybe a little bit too complicated right now, and like I still need to add a lot of features. Higher kind of types useful for proofs. Yes, but the I think the inference, I read about it a little bit. So like there is two different kinds of inference algorithms. There is bidirectional inference, and there's the unification. So what I'm doing is I'm doing the unification. Which is just like, you know, saying that this type is equal to that type, this type is equal to that type, right? And from what I have read, the existing independently typed languages, they don't do unification. They do instead bidirectional type checking, which is a different thing, which is simpler, and is also like supposed to like easier support subtyping and stuff. I don't know. So higher kind of types with explicit types, with explicit like basically being able to have a higher kind of type as a value, right? And explicitly pass it into a function is good, right? What I don't have right now is the ability to infer which higher kind of type is being used, right, for the generic monadic notation. So when I have the do notation and I'm doing some monads, this over here is working on options. But the reason it's inferred right now is because this syntax just not uses any monad, but it uses option as monad, right? But this should be inferred based on the fact that I'm using the monads here, right? And stuff. Based on the fact that I'm using the options here and not any other monad, right? So the inference... so like we do have monads, but we don't have like the inference is incomplete right now for some reason. Anyway, and yeah, as I heard, there is this other bidirectional inference, which is supposed to be like easier, a lot simpler, and yeah. But it will not be able to infer as much stuff as we currently do potentially. So I don't know. I just heard that existing independently typed languages don't do what I do. Alright, anyway. Thank you guys for watching. See you next time. Bye.